I'm fine, thank you. What about you?
Fine, also.
So, I'm good.
Let's start the first presentation.
So, the first presenter is present right now, James
Yes.
Taylor.
Yes, I'm here.
Is how many presentations are present here at this?
We can check.
Itamir is
Yeah.
there.
Yes, I'm here. Let me see. We have. Is there any other presentation in the room from SEPA 5? Please identify yourself. Okay, maybe not yet. But, can we start with this one, Professor? Because of the time.
I can see only one, right?
Yes, only one now. The James.
I think let us wait for some more participants, maybe 5 minutes.
Okay. Let's wait.
Professor Sanjay is taking breakfast.
Yes.
Let's.
Hello.
Hello. Shall we? Let's wait some minutes.
Yeah, maybe 2 minutes, 5 minutes.
Yeah.
5 minutes. Okay.
So there is only one presenter is there, right?
Yeah.
The first one.
The first one, right. Mr. James.
Let me start working on the
Hi, morning.
Morning.
Is the question, is there any other presenters on the call?
Yes.
Yeah, I'm a presenter, but only scheduled for I think in 20 minutes time, yeah.
Okay, what's your name?
Russell Peterson.
yeah.
Russell Peter, 920, right?
Yeah.
Okay. Just a minute.
Rasan Peterson, okay. Towards the explainable, okay. Mhm. Who is this one? Aaron Junior. I think let us start.
Okay.
We already have two.
Okay, so let's start. Mr. James, please.
Okay. Can you see my presentation?
Yes.
Okay, let's start.
Yes, we can see.
Okay. Hi, everyone. Professor Sanjay, I'm facing some problems with my internet signal. I hope no problem, but if it happen, okay, let's try.
Don't worry. Please go ahead, okay.
Okay.
We are with you.
Okay. Thank you for joining me. My name is James. I'm from Brazil. I'm here to present you this paper, Native, a framework for agile software development, self-oriented architecture, and quality assurance. This paper was done by me and Professor Sergio. We are researchers linked to the University of Brasilia. I will talk about this hard context we have played every day. Working with software development could be a crunch because things change all the time. and people ask for new solutions when we did not finish the previous solution request. This is my agenda for today. Our goal with this paper is provide a foothold to help us navigate the problems that arise in this context. Nowadays, I work in a government environment where needs are constantly changing. The laws and requirements of citizens conduct the actions of the government agency where I work, and both can change at any. In this ever-changing environment, we must respond with flexibility, speed, and quality. We need to deliver software on time to meet the laws and wishes of internal customers and end users, the citizens. This blurry scenario leads us to the problem in this paper: how to do it, how to develop software with quality and rapid deliveries in an ever-changing environment. Well, we did researches in the literature looking for a solution that helped us deal with this problem, and we found some answers. After we evaluated these answers, the concepts of SOA and Agile have attracted us. Then, based on these studies and also in our experience, we've decided to build a solution that deals with the problem using the concepts of SOA and Agile. This solution came in the form of a framework we've named Native. At the beginning of the build of the framework, we've realized that something was missing. It was the need to maintain or improve quality. So we've added the concept of quality assurance. We focus our effort in these three main concepts: service-oriented architecture, agile development, and quality assurance. SOA and Agile are business-oriented. SOA directs business objectives to services, and Agile deals quickly with requirements and changes in it. SOA allows us to reuse the functionality of existing systems and integrate with new features, while Agile enables us to quickly and flexibly exploit these SOA features. SOA and quality assurance need a well-designed process, while Agile is a lightweight and less documented method of development. We've had to deal with these three concepts, using their strengths and managing the trade-offs in our framework. The native framework has four layers and 13 phases. We've tried to join in one development lifecycle the main principles of the three concepts: SOA, Agile, and quality assurance. In fact, the framework has four operational layers, but it has two symbolic layers representing the stakeholder support. These symbolic layers permeate the entire framework to remember that without this support, the project may not run as desired. It may not even be completed. The entire framework is iterative, which means that we could return to the previous phases from any phase. For example, if we don't understand the nuance of a requirement, we can back to the plan layer and refine our understanding of that. Another example is, if some functionality is not approved in the acceptance tests, the work could return to the code phase, a phase in the same construction layer, or return to the design layer, or even to the initial plan layer. Each phase has its purpose, and we can describe them in terms of leading roles, inputs, tasks, tools, and outputs. The terms used in this paper are samples. The name of the leading roles, for example, may change depending on the environment. As a framework, it's not exhaustive, and its concepts, inputs, tasks, and outputs may change and adapt to each environment. Let's see a little bit about each of the phases of the framework. The plan layer. We can say that this layer has a concurrent process. That is, the phase may occur simultaneously. Here, we try to balance planning and documentation, a need for SOA and quality assurance. This balancing is a concern that runs throughout the framework, and we have to keep track of the whole process, but just enough to avoid harming agile principles. In the face of this layer, the sponsors, or you may say product owner, and the business analysts or project manager work together with the designers, testers, and quality assurance team to kick off the project, identifying the high levels of requirements and architecture. The design layers is iterative. The work goes around the phase until the design is good enough to go to the next layer. In the phase of this layer, the designer and clients, together with the business analyst and tests and quality assurance teams, refine the requirements and try to break them into their smallest parts and drive them to services. They also take care of refining the architecture and tests, and they think about the quality, like, for example, selecting the adequate metrics to evaluate the process and the final product. The construction layer. As with the previous layer, this construction layer becomes iterative. The work goes through the phase until customers accept the functionality. Developers and testers do most of the work at this layer, but IT operators and clients also have significant work. IT operators, for example, need to prepare the build of services in test or stage environments. Clients do a critical job. They assess the results of the development, and if it's okay, the job goes to the next layer. Otherwise, restart the iteration. The execution and monitoring layer. The phase in this layer runs continuously. That is, each phase process never stops. Preparing system for production, releasing them to the use, constant monitoring, and reporting the errors found. In conclusion, the framework pays attention to the values and principles of the three main concepts: Agile, SOA, and quality assurance. It allows the building of a well-structured process that acts on essential factors for a fast and quality delivery of the final products: enough initial plan and adequate software architecture, achievement of business objectives, dividing them into small pieces and directing them to functional parts of the software, iterative development fitted to observe changes instantly, code and integration tests and acceptance tests to detect errors during the development process, monitoring to detect problems while running the system. As future work, we are preparing a case to validate and evaluate the native framework. That's it. Thank you all for having me.
Thank you, Mr. James. Any questions? Okay, I have one. So let me see somebody. Okay. Tell me, you told that you present this framework, and I was asking myself here, what is the artifact that you planned for each phase of Gen? Do you have?
Yes. Yes. Thank you for the good management of the time for the presentation. Right, first thing. Second thing is a interesting presentation. I have a question at this time that how this framework means, what is the validity of this framework? You wrote that you are going to do into the future, but what is the initial validation?
Okay, Sanjay. One. How do I stop my presentation here? Okay, so one
It
more.
already stopped.
Right? Okay. Okay. I'm here. Sanjay, can you please repeat the question?
Yeah, my question is, means you have written that you will do some validation in future,
Yes.
right?
Yes, we are
But
carrying out
what is the initial validation?
a case study in using the framework. We got a team that was developing software, and we made some measures with some metrics, and we evaluate these metrics, and we take some metrics, initial metrics, and then we apply the framework, and we are evaluating the evolution of these metrics in about using the framework. Okay, how these metrics evaluate in the time. We already did this case student. We are preparing the results for present. Who knows in the next ICCSA 2021 new paper.
Okay, so you have already applied in your projects, right? Is it true? What I understand, you already applied in your running projects, right?
Yes, we already applied the framework in a real environment. Okay, but we haven't the results. We are preparing the analysis. We are done the analysis of the results, and we prepared new paper.
Okay, so I hope that the new results will be in the ICCA 2021, right?
Yes, okay.
You will again present the extension of this work next year,
I
same
hope
time.
so. I hope so. Uh,
Okay, so maybe we will see you together again. Thank you for submitting. I think, is it your first time to submit your paper in ICCSA, right?
what? No. This work is a sequence of a paper that I presented in the St. Petersburg, Russia, last year. I was there.
Okay, okay, you presented. Okay, you was there. Okay, okay, you was there.
Yes.
Okay,
I
okay, okay. Thank you very much. Okay, to being with us again. Yes, say something you wanted to say.
hello.
James, say something. You wanted to say something.
What? No, no. I think Itamir has a question too.
Yes, about the artifacts. Do you have some artifacts for each phase of your framework or something like that?
Yes, in the paper we have a more detail of the artifact. And now we have only 8 minutes
It's
in.
okay. Thank you so much. Itmir,
What?
Itmir, go for the next presentation, please.
Oh, okay, so no problem. I can
Thank you,
talk to you
James.
later. Thank you, James.
Thank you all, guys. Thank you.
Thank you.
The next presenter is Mr. Russell Pedersen.
Is Jerome has joined the room? I called to the second author. He is saying that he is joining.
Okay, no problem. The
So, but
one
ask to
from
the third author, he can present.
Okay, so should I go ahead, Salam?
yes, I think so.
Okay.
Yes, yes, you can continue.
Can you see my screen?
Yes.
So good morning. My name is Russell Peterson. and I'm going to be presenting a paper title towards explainable direct marketing in the telecommunication industry through hybrid machine learning. So the authors are myself and Olawanda Taramula, and we are from the Cape Peninsula University of Technology in Cape Town, South Africa. So just an introduction. So with vast amounts of data available, marketing the right product directly to the customer at the right time can be challenging. So machine learning has been proven to be an effective way to make predictions when comparing against traditional statistical methods. But the disadvantage of machine learning models is normally that results are produced without an explanation. This results in a lack of confidence in machine learning frameworks. So this research presents a design framework which explores a hybridized framework which combining supervised machine learning and intelligent reasoning model to actually to produce an explanation with a result. So most direct product marketing tools are based on machine learning, but because of a lack of explanation, this results in reduced levels of trust and reliability, and also confidence. Also, it requires a high level of skilled resources to actually compile data sets and also explain and interpret the results. So this has an impact on the confidence in making decisions based on these results. So the consequences of this results in a low uptake in machine learning based solutions. So the related work which we have looked at have all indicated that machine learning is effective in predicting which customers to actually to sell a product to. And then also some more related work have shown that case-based reasoning, there's great value in contributing to the decision making and also generating explanations. So our solution is actually combining machine learning with case-based reasoning. So the requirements of our framework will be to predict customers which is likely interested in a specific product, also show customers who's not interested in products, and the framework should allow for multiple machine learning models to be applied, and explanations should be easy to understand, and predictions must be produced in a speedily manner. So basically, this is a high-level view of our framework. So a study by Chen has showed that the telecommunication industry normally comprises of these three layers: a resource layer, a service layer, and a customer layer. But an additional study which we have looked at have also shown that the billing layer is quite important. So our data set would be derived from these four layers, which is the resource, service, customer, and billing. It will be passed to the hybrid machine learning framework, and then a prediction will be produced as an output with an explanation to the user. So this is a workflow of our framework. So it will go through the data gathering, data wrangling, and then it will label the data. And then it will actually look at the features. Then it will pass the data into the case base. So it will then look, is the case similar? If it is, the case-based reasoning module will then do the prediction. If it's not, it will pass it to the supervised machine learning model to do the prediction, and then it will then attach an explanation to that prediction. So we actually took some real life data, and this is what that data would look like when it comes from the layers, and this is what it looks like after the labeling has been done. So these are the three machine learning models which we would look at. It's the support vector machines, random forests, and the artificial neural networks. Then our case-based reasoning model would be based on this model. So it would have four phases. It would take a new case. It will then look, has this case been has it occurred before? So then it would get that case, and then it would actually then produce um, a prediction. So our case-based reasoning would also comprise of a similarity threshold of 0.8 and above would then be considered as a case that is similar. And then the domain rules, which is captured by a domain expert, would then be used to create that explanation. So this is a sample of what the rules would look like in the framework. And this is, as I mentioned before, is captured by a domain expert. And then this is the general architecture of the framework. So the user will be presented with a GUI and then load the data, and then the data will then be processed. And then once the data has been processed, it would be passed to the middleware where the CBR would be interacted with a RESTful API. And then also the prediction would be executed by the machine learning model here, which which resides in the scikit-learn framework. And then the outputs would be the prediction by the CBR or the prediction by the machine learning model, and then the explanation would be attached and produced as a result. So in conclusion, due to a lack of explanation with machine learning frameworks, a hybridized architectures comprising of machine learning and CBR can address this lack of confidentiality which stems from that. And then also what this demonstration has shown is that a process framework can be applied in a real problem scenario as we looked at the real life data. And in this contribution of this research is that it offers a new perspective on how a product can be marketed directly to a customer by using a hybrid machine learning architecture. And in further work, we shall take steps to implement this proposed framework and conduct an evaluation. So thank you for giving me the opportunity for presenting this. I really appreciate it. Thank you all.
Okay, thank you, Russell. Any questions?
I think there is a
Thank you,
question.
Russell, for your presentation.
There is a question in the chat. If you from Professor Alphonse Misevich.
Oh, yeah.
And any questions, please? Hello,
Professor.
from anybody? Russell, have you applied this framework? I have a
Okay.
question.
Yeah.
Have you applied a framework?
Okay. So once we develop it, right?
So,
Yeah. So once we develop it, a user would actually be presented with a GUI or front end, and then you load the data in there, and then a user would actually be able to select which machine learning model you would like to apply in this in what to his data, and then the framework would then take uh, every occurrence and check in the case-based reasoning, has this case occurred before, and is it similar to the current one now? So if it's similar, then the case-based reasoning module will then execute a prediction, and if it's not, then the machine learning model will execute a prediction.
it's okay. It's okay. There is something, I think, in disturbance in the internet. Voice is, audio is not very clear. It's okay. Thank you so much. Any other presenter available in this room at this time? Any other presenter present in this room at this time?
I believe there is
Hello.
a question from Professor Misevich still unanswered.
Hello, sir.
Yes, please ask.
He says in the chat, can genetic algorithm random forest apply? I guess.
Sorry, I didn't get that question.
He says in the chat room, can genetic algorithm random forest apply? I don't know what is.
Yes, so the idea of the solution is that it's a framework and you should be able to apply any machine learning algorithmic model. So it's not limited only to those three. You should be able to replace or insert any machine learning model which you would like to have in there.
It's okay.
Okay.
Good morning.
So, Itamir, I think in the absence of anybody, we can close the
Hello,
session.
sir.
We will meet after
Good
20
morning. I
minutes,
have a
right?
presentation, sir.
Anybody is,
I have a presentation,
who
sir.
is on the line?
Noah from Landmark University.
Good morning, sir.
Noah from Landmark University.
You have a presentation now?
Yes, sir.
Okay.
Okay.
What's your paper?
Noah from,
Landmark University.
what is the paper title?
A dynamic rand triple DS cryptographic technique for data security.
Okay.
So, what is your name? What is your name?
Akande Noah.
Akande Noah.
Akande.
Noah.
Tobi, I think Noah
Yes.
is not there. Okay. Go ahead, please.
Okay. Good morning, everybody. I've shared my screen. Please, can you see it?
Yes.
Okay, thank you, sir. Good morning, everybody. My name is Noah from Landmark University. First and foremost, I want to appreciate Professor Mishra for giving us the opportunity to be part of this conference. We are very grateful. I'm here to speak to my presentation titled A Dynamic Rand Triple DS Cryptographic Technique for Data Security. These are my presentation outline. I will start with the introduction. Now, security is a serious issue of concern in an everyday activity. As a software developer, before you deliver that software, ensure you put at least one security technique in place. This is simply because the frequency and complexity of data and cyber security breaches are on the increase. According to biggest data breach statistics, 8% of government parastatals were affected in 2018. 29.2% of medical and healthcare institutions were also affected. And 45.9% of businesses were also affected in 2018. This shows the increasing rates of data and cyber security breaches. And every data and cyber security breach will always come with a cost. According to 2019 cost of data breach report, the global average cost of data breach in 2019 was put at 3.92 million, in contrast to 3.86 million recorded in 2018 and 3.62 million recorded in 2017. Recently, some Nigerians were involved in COVID-19 scam, and those Nigerian guys scammed United States to the tune of $35 million just in one day. This has showed the effect of data and cybersecurity breach. With these statistics, regardless of how simple it may be, organizations and software developers need to implement at least one security technique to guarantee the security of their software and data. Now, there are different security techniques that could be put in place, but this presentation will focus on cryptography. Cryptography techniques have been widely employed to ensure confidentiality, to maintain integrity, and to guarantee availability of our sensitive and valuable data. Now, cryptography involves, with emphasis on cryptography, it employs a secret key to make a message unreadable. That process is called encryption. Such message can only be read by the intended recipient through a process called decryption. Now, cryptography could be symmetric when the same key is used for encryption and decryption. And cryptography could also be called asymmetric when different keys are used for encryption and decryption. Now, this presentation will focus on data encryption standard cryptography technique. It is a symmetric technique that uses the same key for encryption and decryption. I will quickly give a brief overview of what DES algorithm is all about. DES is a 64-bit block cipher symmetric cryptographic algorithm that uses 56-bit key for encryption and decryption. As a 64-bit block cipher, DES divides data into blocks of data and encrypts 64 bits of data at a time. That means if I have 640 bits of data, DES will divide it into 10 blocks and encrypt it at 63 bits per time. Now, DES uses permutation and substitution operation for its encryption and decryption process, just like other cryptographic algorithm. Now, substitution entails replacing a value with another value, while permutation reorders the positions of the bits in the input data. These processes are repeated in a number of times called runs, and it is generally believed that the more the number of runs, the higher the strength of the algorithm. Now, presently, the conventional DES employs 16 runs for its encryption and decryption process. Now, this presentation wants to maximize this saying that the more the number of runs of a cryptography technique, the higher the strength of the cryptography technique. Now, why are we proposing to improve on the performance of DES algorithm? The conventional DES algorithm is vulnerable to key attack. Therefore, its strength is dependent on the key to be used. Now, to make DES more resistant to key attack, triple DES was introduced. Now, triple DES uses 3 different keys to encrypt, to decrypt, and encrypt each block of data. This means that the total length of keys used for the encryption, decryption, and final encryption is 168 bits. Now, several modifications of DES have been proposed in the literature. These have been captured in related works included in this study. So this study proposes a dynamic round DES algorithm. Now, the dynamic rand DES in the dynamic rand DES algorithm, the number of rounds for the encryption and decryption will be specified at runtime by the user. This means DES algorithm does not need to only use 16 rounds for its encryption and decryption. A user can decide to use 20 rounds for its encryption and decryption. A user can decide to use 40 rounds for its encryption and decryption. Now, this is the methodology that will be used in the proposed DES modification. Now, emphasis will be on the number of rounds that will be used for the encryption. This number of rounds will be specified by the user at runtime. Now, with this, DES algorithm will not be limited to 16 rounds for encryption and decryption. It could be 20 rounds, it could be 25 rounds, it could be 30 rounds, it could be 35, as specified by the user at runtime. The algorithm the algorithm to support this methodology is included in the article for this study. Now, to evaluate the performance of the proposed technique, an electronic medical information system was developed to evaluate the performance of the proposed technique. As we all know that an electronic medical information system, we always keep sensitive textual and graphical information of patients in a hospital. And those information are very, very sensitive. It must not be accessible by a third party. So after entering the needed patient information in form of text and image into the electronic medical information system, the personnel in charge will employ DES algorithm, the proposed DES algorithm for encrypting the patient's information. Now, the personnel will be expected to supply the number of rounds for the encryption and decryption. In the interface displayed on the screen, you will observe that 20 rounds was specified by the user. That means 20 rounds will be performed for the encryption and decryption process. Now means 20 rounds will be performed for the encryption and decryption process. Now, for anybody to have access to the information that was supplied, for anybody to have access to the information that was supplied, the right number of rounds must be provided. If a wrong number of rounds is provided, deciphered, the actual data will not be displayed as shown on the screen. Now, once the correct number of rounds is supplied, the patient's data, textual and graphical data will be displayed on the screen. Now, the performance of the developed system was evaluated. The processing time of the developed system was evaluated. Now, you observe that when the traditional DES was used, if 16 rounds was specified, the encryption time was 80 seconds, while the decryption time was 77 seconds. Now, if the number of rounds is 17, the encryption time was 89 seconds, while the decryption time was 87 seconds. Now, as displayed in table 1, it was observed that as the encryption time increases, as the number of rounds increases, the encryption time and decryption time also increases. But in real life scenario, processing time could actually be traded off for security. People are interested in securing their sensitive documents regardless of the time it takes to secure the document.
Okay, that's all.
I think
In real life scenario, processing time could actually be traded off for security because people are much interested in securing their sensitive documents regardless of the time it takes to secure the documents. Now, furthermore, avalanche effects of the proposed modified triple DS was also measured. Now, avalanche effect measures the degree of diffusion of a cryptographic technique. It is used to guarantee that any little change in the input plain text will have a corresponding each change in the ciphertext. Now, the avalanche effect increased with an increase in the number of ramps. According to, as displayed in the table on the screen, it was observed that as the number of ramps increased, the avalanche effect increases. This connotes that the degree of confusion increases with an increase in the number of rounds, which is actually a good result. However, the avalanche effect of the modified DES with 16 rounds was evaluated with the traditional DES with 16 rounds, and a higher avalanche effect of 90.43% was recorded by the traditional DES against the 87.50% achieved by the modified DES. This shows that the modified DES has a higher avalanche effect than the traditional DES. In conclusion, this study has explored the possibility of making the encryption rounds of DES user dependent, which means that traditional DES does not need to use 16 rounds for its encryption. It could be 20 rounds, it could be 25, and it could be any rounds as specified by the user. And the more the number of rounds, the more secured the algorithm is. Now, our increasing sensitive data and information need to be protected from unauthorized access, manipulation, and alteration. The effect of a small breach of data could cost an organization a huge amount of money and undermine the confidence reposed in their software or services. It is advisable for organization to implement at least one cryptographic technique to protect their sensitive data. So this article has presented a modified DES cryptographic technique that could be used to secure sensitive data and information. Now, though the modification yielded an increase in encryption and decryption time, the performance evaluation results carried out reveal that the technique's avalanche effect increases with an increase in encryption round. And the higher the avalanche effect, the greater the assurance that any small modification to the plain text will have a huge noticeable difference in the cyber text. Thanks so much for listening.
thank you so much.
Yes, sir.
Noha, any other paper from you to present in any incoming time?
Yes, sir. By 12 o'clock.
12 o'clock in the third one. It's okay. So, any other remaining guy from this session? And I also invite everybody for the question and answer. Please. Itme. Idame.
Well, Professor, hi.
Yes. So you have any question? You are the chair. So I'm assisting you.
Yes, I can. I have a question. Actually, I saw the system that you developed for evaluate the rounds of the algorithm based on electronic medical records. So uh, I saw that you used also an image to evaluate the time. I would like to know more about the test you did and how big was that results, because we have here an image, we have some data, use everything to cryptograph.
Thanks so much for your question. Now, in the majorly information about patients are always in form of text and image. So any security technique that will be proposed for such software should be able to secure the textual information and the graphical information. That is why I secured, I developed a software to secure the textual information and the graphical information. Now, securing both the textual and graphical information will always come at a cost. That's the reason why if you study the processing, the encryption time as displayed in table 1, if the conventional triple DS was used for the encryption, because we are encrypting text and image, the image used in the for the evaluation is up to
Okay.
1 MB. That's the reason why the encryption time was an hour. The encryption time was 80 seconds, 1 hour and 20 minutes, while the decryption time was 77 seconds, which is 1 hour and 17 minutes. So if the image to be encrypted is heavy, it will always have effects on the encryption time and the decryption time of the system. Now, if the traditional DES was used, the encryption time will be 1 hour 20 minutes. Now, as the number of runs increases, the encryption time will also increase. But just as I said in my presentation, people may not really be interested in the number of hours it will take to secure their data. They should be interested in what will be the effect of a data breach to their software company or to their organization. So if it take an hour for me to secure my data, then people may not really mind, although this can be improved on.
Okay, thank you very much. Okay, Professor.
Identification of criticalities embodied in the spatial, material, and socioeconomic.
So we close this session. Wait, the next from this session we have 3 presenters, right?
Yes, 3 presenter, yes.
So the SEPA 6 start at 10. I have
Yeah,
5.
after 6 minutes, yes.
Okay.
Yes, I have one more
Sir, good
question.
morning.
Yes, who is on the line, please?
Somebody, this is Amarendra. Yesterday I missed my presentation due to technical problems. Is there any chance to get it
It's okay.
to present now, sir?
1 minute, please, sir. Itmir, have you included his presentation as a present yesterday?
No, I didn't, because he didn't present.
No, he has presented. In fact, he tried, and
Yeah, sorry. Yes, I did.
you did it.
Yes.
If you are sure, then there is no any need to present again, right?
Yes, true. But he had some technical problems. And,
Yes. He has some technical problem. So you have already filled the form for the evaluation form, right?
Yeah, let me check here just a moment, because I guess.
But how will you check? Because you are not getting any email.
Because I have a list here. I first do in my forms, and then I pass to the form.
Okay. So you check it. Mm-hmm. I think you did it.
Risk management framework, right? Amarenda?
Yes, filled.
Yes, sir. Yes, sir.
I did.
It is filled. So thank you so much, sir. No need. Yesterday when I observed that there is a problem and I was not sure that it will be resolved by tomorrow morning. We are in Africa, so it is not very easy to solve the issues. But you solved it, it's okay. Thank you so much for coming, but it's okay now.
Okay, sir. Thank you.
Okay.
Thank you very much,
Yeah,
sir.
you are welcome. So I think there is no any presenter for now. If you have any discussion or something, you can discuss with us for the next 5 minutes. Otherwise, it is a 4 minutes break from now. She has not written her name. What's your name? Yes, I'm asking to you, a new lady coming from Arab, right? Either Turkish or Arab.
It's muted.
You have muted it. You muted your mic. We only see your lips moving up and down.
Yeah. My name is Samah Abu Salim.
From
I
where?
am from Palestine, but I am a student at UTHM Malaysia, University Malaysia.
Okay, you are UTH Malaysia. Okay, you are from the Malaysia now.
Yes.
So when is your paper?
My paper. The title is analyzing the impact of assessing requirement specification on the software development life cycle.
Okay, when is your presentation in SEPA 6?
At 6, yeah, at 6.
Yeah, at 6. SEPA 6. So we have 4 presenters at SEPA 6.
Yes.
My dear audience, means all those authors, please change your GIST name with your own name so we can identify yourself. I can see the new presenters. You can change your name. So, Thais, you are welcome.
Yeah, thank you. I'm happy to be here.
Yes, me too to see you because where is your presentation? SEPA 6?
My presentation is designing a patient-centric system for secure exchanges of medical data. It's on 11:30 on the schedule.
Okay, 11:30. This means.
But I can start.
11:30 means this is the next SEPA 7, right? It's okay.
Yeah.
We are presenters. David, you are welcome.
Hello. I have in 1 minute.
Where is your presentation, David?
You're lagging a bit. Perhaps I have. Okay, so am I supposed to share my screen then?
No. Yeah. At what time your presentation is?
It's 10 o'clock.
In 1 minute.
Okay, at 10. So we are starting at SEPA 6, right?
Yes.
Say what again?
We are starting the SEPA 6.
It's a bit unclear. I can't hear correctly. Sorry.
We're starting SEPA 6, so you can present your screen and wait till 10 o'clock and start the presentation. Okay, Professor?
It's okay.
Yeah, share your presentation. When we get to 10 o'clock, you can start.
All right.
UX systematic review.
Okay, I will share now.
Is the second presenter is ready?
Is there any other presenter here? We have.
Oh. All right. Can you see my screen now?
Yes. You can continue.
With the presentation. All right. Hello, everyone. Nice to meet you all. My name is David, and I wrote a paper on Lean UX, a systematic literature review of that with my teacher Ricardo Colomo Palosos.
Hello. Hello,
I'll
yes.
start with defining what Lean UX is. Lean UX is a software development method, which is basically divided into 3 core principles, which are lean thinking, lean startup, sorry, which is a method for reducing project risk by rapid development and learning. And lean startup is focusing on reducing wasteful innovations by solving problems for the real users with user-centered methodologies. While design thinking is kind of the same, but it's an iterative discipline designers use so they can design products or solve problems rather for users by understanding what the user wants or need in their lives by observations, which could be also interviews and so forth. And the last core principle is agile development philosophies, which is a method for delivering working software continuously to the customer. And Lean UX as a whole aims to design, develop, or deliver user-centered products iteratively and incrementally as fast as cheap as possible by developing small features called minimum viable products. These minimum viable products are tested with the representative users to identify whether the concept or business model is viable or not. And these user tests provide feedback to the team, where the team can evaluate the results and pivot the business model towards the market need. And this process are done incrementally and iteratively until a product is viable or not. And the method I used was a systematic literature review. So I defined a few databases that I would do my search based on. And I also defined 4 research questions and a search string. So we see here that I have 4 research questions, and I wanted to answer how Lean UX was defined in the literature, what the reported benefits and challenges of Lean UX were, and how Lean UX has evolved over time. And as you can see here, we have the search string that I used on ACM, IEEE, Springer, Science Direct, and Google Scholar. I had 4 stages of filtering when I got my results by the search string with a set of inclusion and exclusion criteria. And in the table here, you can see from filter 1 to 4, the number of papers that I selected reduced quite a lot, ended up with 12 relevant papers for my article. And in the literature, most of the definitions in the results were cited from the book Lean UX, Applying Lean Principles to Improve User Experience, which was written by Jeff Gottolf in 2013, if I remember correctly, which indicates that this book is the main source of information regarding Lean UX. The results also showed that there were quite a few similarities on how the authors defined their definition of Lean UX. And the general definition was that Lean UX were a fast iterative approach for creating user-centered products with the use of the core principle, minimum viable products, and user testing, which I kind of explained in the intro. It was also found that in a paper that they presented a manifesto for Lean UX with 6 core principles, which the community made similar to the Agile manifesto. And we have research question number 2, which were the reported benefits. And by the results, it seemed that it was a great technique for releasing products aimed for the market. It was also found that Lean UX helped team realize their ideas quite successfully by creating the minimum viable products, because they could then obtain continuously user feedback and alter their designs accordingly until the product was finished, which in the results they told that they saved a lot of resources when they created these smaller features, and they got a more user-centered product, and then help the developers understand what the product value of the applications or website would be. It was also found in the results that Linux were beneficial for team collaboration, as Linux provides methods for creating a shared understanding of the development, because they are working across disciplines. It would also seem that this would provide some better quality, as the product is or were assessed across multiple disciplines, for example, such as designers and non-designers. This was done in one of the papers they discussed this. And we have research question number 3, the challenges. And in the results, it showed that communications were quite a challenge, because in a lean or agile environment, the development are rapidly changing. So coordinating must be done consistently. It seemed also to be especially the case when adopting Linux to larger corporations, because a common understanding of Linux by UX people is that it requires less documentation. We also had another issue, was that adopting Linux would seem to be a challenge, as team structures in Linux environments might be different from what the current company have. So when they try to adopt it, they have to restructure the teams accordingly, and perhaps they don't have the right people to fit in that team structure. And lastly, we have the research question number 4, which you could see a table on the right. We have the number of papers discussing Linux over the past years from this systematic literature review. And the results suggest that the evolution of the concept have been discussed moderately over the past years, but not extensively. And the book written by Jeff Gottolf was published in 2013. And if you could see on the table, that kind of indicates the growth of the discussion before that. It was also seen that larger companies such as PayPal have also adopted the Linux principle, suggesting that Linux is starting to get attractive. Thank you.
Thank you for your presentation, David. Any questions? Okay, David, I have a question.
Yep.
Have you done any quality evaluation of the results papers of the review? Or
say that again, sorry.
Have you done any quality evaluation of the result papers of the review? You showed that you have about 1,000 papers there. After you execute your string.
Qualitative. Well, I had like 4 stages, which I would discard some of the papers rather than others. So, for example, in stage 1, I would, or stage 2, I would read all the abstracts and the conclusions and titles and so forth, and then based on that, I would discard those who doesn't seem relevant. If that answers your question.
Okay, you have how many researchers participate of this review? Just you?
What?
How many researchers have participated of this review?
It's basically me as a student. I'm a student at Østfold University College, but I had a supervisor, which was my teacher, who will help me progress in the paper and help me with the structure of the paper and so forth.
Okay, so thank you very much. Is any other presenter in this room for CEPA 6? Solving one Industry 4.0 midair. Any presenter? Maxmin. Okay, 10:30. Maxmin, Menshikov.
No, there was a presenter from SEPA 5. The remaining presenter from SEPA 5.
Oh, okay. Is he here?
Because there was a remaining.
Is he here with us, the remaining presenter from SEPA 5?
Yes, he.
So he can present, I think.
SEPA 5, yes. Arom Junior Gabriel is there. Arom.
I'm currently at work now, so I have to leave. But thank you for having me.
Okay, thank you, Dave.
Thank you.
Okay, David is leaving. It's okay. Any presenter for this one?
Yes, we have Maxine, but he's at 10:30.
10:30. Maxim, ask Maxim to present.
Yes, please present, Maxine.
Yes, hello.
Hello. Your
Hello,
sound.
Maxim.
We're almost not hear you, Maxine.
Yeah, good morning. Maxim.
Yes.
The sound, your sound is low, very low.
Who is presenting?
Maxime is trying to present, Professor, but his sound is very low.
6.
Okay.
We almost can't hear you. Can't hear you, Maxime.
Excuse me, sir. Try to configure your microphone settings in the operating system. We can't hear you. All right.
Well, I'm not sure I can make it any better. Can you hear me?
Yeah, yes, you can hear, but you are very low. Your sound is very low.
Okay, I'll try to speak louder.
I
I don't see any way to configure the microphone right now.
I think it's better now.
Okay. Hello, I'm Maxim Menshikov, and I would like to present you my work on midair in intermediate representation for multi-purpose program analysis. I'm a PhD student at St. Petersburg State University, a software engineer at Octet Labs, and I'm doing static analysis research for my PhD thesis based on my framework called EQUID, a static analyzer for C, C++, and RC based on model checking and abstract interpretation. Going back to topic, there are many intermediate representations for different purposes. Some frameworks are compiler-oriented, some of them are analysis-oriented, some are for Java or .NET bytecode, some are for optimization, and there are different kinds not mentioned here. In our framework, we wanted to combine the low level with the high level, but only for static analysis, so that we could have a common language which can be single static assignment if we wanted, not single static assignment if we need it for a different kind of analysis, so that we could have local and remote objects to be able to move execution to a different node in a cluster. We wanted to have a low footprint to reuse as many middle steps as possible, and we wanted to have an arbitrary type system to interpret objects differently for each kind of analysis. The high-level design of our framework comprises 4 different layers, all doing a different job in the static analyzer. We convert source to directed acyclic graph to spot bad abstract syntax tree patterns, and then to control flow graph with DAC elements to spot bad control flow graph patterns. And then the interesting part is a virtual machine intermediate representation and augmented one, which can find specification violations, logical issues, memory leaks, and handling pointers, and other issues. In the end, we get the list of defects as the output, and all representations are tied to semantic storage, which collects the variables and types. Layers 1 and 2 are directed acyclic graph and control flow graph. Our approach for them is based on generalized syntax trees. We get an input in C, C++, or any other language, convert it to abstract syntax tree, and then get a generalized syntax tree which removes the sugar from input programs on different languages. Then we simply get directed acyclic graph and control flow graph as usual. The layer 3 is a virtual machine intermediate representation. It focuses on the semantic meaning of the construction, but preserves DAC expressions. This representation can be converted to single static assignment on demand. For the expression presented on the slide, we can have a very simple representation, which involves reading every variable and value just once, and use many temporary variables. And a reasonably simple representation which tries to reduce the number of temporary variable allocations, but still make the logic simple to understand. The syntax used in the representation mostly remains untouched, so most constructions of the original DAC are still the same nodes as in virtual machine representation. So we achieve the low footprint. The subset of commands supported in these representations are declare, load, init, assign, check, which is really specific for static analysis, constraint, also for static analysis, branch and branch, augmentation, which is discussed later, invocation, enter, exit of block, return an expression, and annotation functions. But really more commands are supported, in fact. The layer 4 is augmented virtual machine intermediate representation. We add some useful knowledge about the program to the intermediate representation, such as SMT representation, abstract interpretation of the command. For example, if we assign something from 1 to 3, we can say that the interval is 1 to 3 in abstract interpretation. We can add some knowledge like the context the function executes in, and so on, so that the engine can have a better model of the program. The arbitrary type system is supported through the API. API takes account of types and gives just one precise low level of virtual type based on the environment. For example, if we have a type in a source, in different environments, it can be low-level type 1, low-level type 2, low-level type 3. For example, if we consider int, it may be int 32, int 64, and so on. The API just takes these differences and gives one specific type for the current environment, and the intermediate representation user can interpret it any way he or she wants. All resources identified by ID can be loaded from or unloaded to the database, and only temporary objects are local. All commands and expressions are serializable and can be fetched on demand. The main supported serialization type is JSON, but binary representation is also considered and in development. We currently use MongoDB, but the engine can be extended to any other NoSQL database system. During evaluation, we found that the type system was successfully used with CVC4 and abstract interpretation models. The overhead of type system for CVC4 is 10%, and for abstract interpretation is around 1%, mainly because abstract interpretation uses, in our implementation, uses generalized syntax tree as it is. All computations were done in a single static assignment form, because we found it's easier to drop versions rather than convert to single static assignment on demand. And we found that intermediate representation preparation takes 10% of execution time, and conversion to SMT and verification takes up to 70% of time. Databases have significant footprint, but memory savings are also significant and can be up to 2 or 3 times. The IR is extensible mainly because the storage structure is not standardized yet. The command size may be big, but it's not that big if we use reasonable intermediate representation kind. The IR is hardware neutral because no level types are predefined. So any user can do anything with intermediate representation. And program semantics is well preserved due to desugaring. The GST itself is close to C-based languages, but will probably be highly divergent from other potential input languages. In our framework, Equid, we use midair for different kinds of analysis, such as data flow analysis, bounded model checking, abstract interpretation, and the usage is very successful, and we are adding more languages with a relatively low cost. At the moment, we could support all the models we aimed for, and these models were actually implemented. In future, we would like to add more virtual machine commands, add more analysis features, and standardize the command storage. In conclusion, the midair consists of 4 layers. 2 of them are quite typical, directed as cyclic graph and control flow graph, and 2 of them are virtual machine intermediate representations, also augmented with different kinds of data. This IR allows saving some RAM and computational power by reusing representations of different levels. Users can cooperate through augmentations, and objects can be serialized and deserialized easily, so we can upload the computation to the cluster. And in the end, our arbitrary types are supported, and they can be interpreted differently by IR users. Thank you.
Thank you, Maxime, for the presentation. Any question? No, I have one. Can you explain a little bit more about your evaluation, all the scenario and everything?
Okay. The evaluation primarily was about the practical experience using the intermediate representations. It's hard to get some measure of how well it fits the framework, because we can't just go and develop the framework for different IR easily. So we just took measures how much time is taken for by type system, type lookup, template lookup. Also, we checked how much is taken by IR preparation, and how big is the footprint of databases. So the evaluation is just as practical as possible.
Okay. Okay, thank you very much, Maxime.
Thank you.
Do we have any other presenter in the room for SEPA 6?
Hello.
Hello, Professor.
Hello. Yes, I think Kennedy has just joined.
We have one? Oh, yes, from SEPA 5, right?
Kennedy. Hello. Hello, Kennedy.
Kennedy Chinedu.
Hello. Nobody is there. I think he is present, but he is
Maybe having some issue with the microphone. Kennedy.
Hello.
Yeah, no response for us, Professor. I think it's Kennedy. Yeah, no response.
He is responding on my WhatsApp, but not responding there. You know, these African authors, they are really, I don't know, they make me pain. I am calling a one guy in from the one session. Kennedy, please unmute your voice, unmute your audio. Kennedy, unmute your
I'm
audio,
here,
please.
Prof. I'm here.
Okay.
But why you are late?
Kennedy,
okay, I've done
it is
that.
the second guy I'm calling. Please present. You should have
Yes, I've done
attend
that,
the
Prof. I've done that.
Please present your presentation.
Yes, I've done
Start your
that.
presentation.
Yes,
What you
I've done that, Prof.
Done. Please start your presentation.
Okay. Okay.
What you have done? What you have done?
Yes, I'm pushing my presentation right now. Yeah, I'm sharing my screen.
Okay.
Trying to share my screen right now. Please just 1 minute. I'll share my screen now.
I hope you prepare the PPT, is not the paper.
Yes, I have my presentation. Let me just share it and then we'll take off.
Sir, total 10 minutes is allowed, and out of 10 minutes we are only calling to you. See, it is 9:30. We are only calling Kennedy since last 20 minutes.
I'm sorry, Prof. I didn't get the precise time, so I'm on now. Okay, can you see my slide now? In the next 10 minutes, I'll present. Can you see my slide now?
No, there is no need. It is not opened even on your system. How can we see?
Oh my God! I'm trying to open this slide. It's already. I've already shared it on the GC platform.
We are seeing your window. I think it's your Windows Explorer.
Oh.
Because even though he cannot see in his own, our internet is very okay, very okay.
Okay, let me. Why is my Explorer not coming up? Share your screen now. Sharing my screen now. Okay. 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 Okay, Prof, can you see my screen now? I've shared it now.
I have already, we are looking your screen since last 2-3 minutes, right?
Oh,
but we can't see your PPTs. We need the presentation, not your screen. We need your presentation, not your screen.
Are you using to monitor, Kennedy? Maybe the presentation is the other monitor.
I've shared it. Oh, what is the problem? My screen is here, and I've already shared this screen and the slide.
Sir, try to share the application and not the screen. When you click on share screen, instead of
not application.
sharing the whole screen, try to share the window.
Okay. Okay. Thank you very much. Can you see my screen now?
Yes. We can see.
Okay, Prof, thank you so much. My apologies. I mistook the time that I was supposed to present, but let me go straight to my presentation. My presentation is on. Yes, I have the floor. I continue.
Yes, continue.
So I'm talking on Industry 4.0 KMI and Elastic Cloud Xiang Ultra-Scale FPGA metering architecture. I'm going to be talking about this subject in the context of the current smart grid evolution currently ravaging the world right now as a result of the consequences of the troubles of climate change. We observed that in the last few decades, there have been some concerted efforts to drop the surface mean temperature of the atmosphere by about 0.9%. So you see, the rise in surface temperature have led to great concern about climate change. And so if you look at this diagram, you see from 2017 to 2019, there have been a rise. And so the only way to reduce the mean surface temperature is to incline to renewable energy systems. And this temperature rise can be, we can have a departure curve, from 3.2 to 5.4 degrees centigrade to about 0.9 to 2.3 degrees centigrade. So the global concern is what initiatives or what technologies can be employed to actually drop the mean surface temperature. And that is why the whole world is going towards renewable energy systems. And so if we go into renewable energy systems, we are sure to succeed in dropping the emission and the high temperature mean surface temperature to as low as 0.29%. And so my discussion this morning is focused on how we can apply an FPGA advanced metering infrastructure within the smart grid ecosystem so as to optimize the whole energy concern, particularly in the developing world. So if you look at a smart grid, we're looking at demand distributed energy resource. We're looking at demand side management and demand side response. We're looking at grid monitoring. We're looking at control with high powered appliances, and then the cost of energy consumption. So existing metering systems do not support full duplex metering. the use of FPGA in the energy industry to support demand side management and load profiling have been very, very low. Standards have not been employed in developing green energy management systems. And then the exploitation of low latency and scalable bit encryption and decryption model to fully harness the potentials is still a current debate. So we looked at all that, and then we're able to develop a framework that is less environmentally, that have less environmental impact, low cost, that minimize energy waste, that supports high scalability, disaster recovery, resilient and robustity. These are the concerns of a global cloud infrastructure that will harness this grid ecosystem. So our objective here is to develop a model for a green management system using the cloud virtualization infrastructure controller, and then using an FPGA controller as the processing core for the activities within the cloud and at the edge of the end users. So I'm looking at low latency here, high reliability, the effect of fast edge profiling for heterogeneous and then non-heterogeneous cloud virtualization infrastructure. And then we're able to come up with a simulation that will validate FPGA hardware acceleration for low latency, resource utilization, and then throughput. So now, okay. So I have addressed some research gaps as highlighted on the screen. So these are my research gaps from the literature that were carried out: no FPGA integration, lack of metering infrastructure for load and end user load profiling. The use of cloud computing to manage demand side management is still on the increase, and the existing systems for remote data storage have not been fully explored. So we have to come up with a methodology of carrying out some survey in Nigeria. Nigeria was used as a test bed where we carried out some survey with some renewable energy stakeholders to find out what currently is on ground. And we looked at data samples of energy feedback integration, remote storage, and security consideration of their entire renewable energy infrastructure. And then we're able to come up with some hypotheses and some internal consistency tests. And after all this, we're able to now generate a global model that supports microgrid system, cloud advanced metering infrastructure, and distributed cloud computing network. And then we use service-oriented architecture with software-defined lifecycle for an application that runs on the cloud. We developed that, and then we're able to now carry out some simulation experience for fast edge computing profiling when users are using these metering systems to run their domestic activities. Now, one of the consideration we did was to look at a typical deployment of a 50 kVA microgrid that is installed in one of the research institutes in Nigeria. We discovered that this 50 kVA generates energy, but there's no metering, no measurement integration. So our idea was to re-engineer this system using an FPGA advanced metering infrastructure and then push all the energy profiling into the cloud. And so in doing that, we have to look at the overall infrastructure and then consider how we can integrate it. And so this is what we did. We re-engineered it by bringing a smart advanced metering system that is based on FPGA and then link it to an RF modules into the cloud for demand side management and for enterprise analytics. So this is the re-engineered Industry 4.0 framework for our smart grid cloud AMI. At this end, we have the distributed energy resource from different sites at the low edge. And so this is where the edge computing profiling takes place. And then we have the advanced metering infrastructure that is based on Xiang Ultra Scale FPGA, for each of the sites. And then they are connected through an API and then down to the cloud. And so this simplified infrastructure is our re-engineered concept of what is already on the test bed in Nigeria, because we discovered that many of the existing renewable microgrid infrastructure, many of them are not metered, for end user profiling and then allowing demand side management. So what did we do? We were able to build our metering system, of course, based on FPGA, and then connect it to end user loads. The system have a metering profile program with VHDL for Xiang Ultra Scale MP system on chip device. That's the KAMI. Then we're able to set the tuning parameters. We're able to configure the signal, what they call it, signal conditioners for internal processing functions. And then we're able to introduce our security for cloud processing. Of course, that's based on what we call transactional function algorithm. Now, this is the next metering front end and the cloud back end, represented by the cloud transaction framework, highlighted above. So on the cloud, where the transaction will be taking place, we have to adopt an architecture known as the spine leaf architecture. In the spine leaf, we're able to aggregate all the modules that will help us to achieve a seamless and a low density traffic transaction. We have an open flow logical interface that contains the firewall, the switches, and the volume balancers. And then we'll have the storage, and then we'll have the cloud internet where the users can connect, from their remote location. So even with your phone, you can connect to the cloud and see your consumption profile, and then know what is happening at your metering side, and then be able to take demand side decision. So this is the cloud integration layout. From the point of user connection to the cloud, where we have instances of virtual servers. All of them are having those interactions. And then our concern is on how to balance the traffic workload from the end user into the cloud for them to assess the consumed energy profile from their end. So this representation shows our enterprise energy analytics tracking cloud portal, which runs on the virtualized machines. So a unified infrastructure is represented below on the screen, where we have the microgrids connected to the battery banks, and then at the end of the day, connected to our FPGA metering interface, which through the RF connect to the data center and then connect to the cloud. So this is a unified, infrastructure for our smart grid system. And this is a global model we generated from the system, comprising of the PV plants, the metering infrastructure, and the distributed cloud, where we use internal consistency Krobancher alpha test to link them together into the smart grid energy management console. Okay, so I'll go straight. Okay, this is internal representation of the servers in the cloud and the interaction that comes from the end users. So any user that connects to the cloud is going to find his or herself in this, logical isolated servers where their demand side management and the activities are being, provisioned and managed. So we developed a conceptual framework, the cloud virtualization infrastructure controller that connects the users down to the servers. The servers are embedded with FPGA resources, which is what we're going to be testing out. For every user that connects to his or her account through the cloud, we'll have the hypervisor that actually links them to their the servers where their energy profiling and the demand side management is, being harnessed. This have a significant impact in the overall energy transaction from the end users into the cloud. So we're able to set up the tuning parameters for the virtualization controller for our FPGA metering system. And then we were interested in trying to find out what is the impact of the traffic workload on the resource utilization. What is the impact of the latency, on the traffic workload, and then what is the throughput response? So we were able to observe that under the influence of our FPGA KAMI, the utilization was quite significant. We have very high utilization, and then when we have heterogeneous, workload, and then when we do not have heterogeneous workload, and then we have a certain percentage, about 78-41%, in that order, as detailed in the paper. For latency, we observe because of the overhead associated with the cloud virtualization controller, we have much more significant latency but it's quite acceptable, about 0.001, which is very significant for activities on the cloud. So we're able to observe this latency, but that can be moderated and then reduced as much as possible by adjusting some of the tuning parameters so that we'll have a much more lower under the virtualization controller. Now we'll have under response, the throughput response, when we'll have the traffic workload on the cloud. And so we discovered that under the influence of the heterogeneous VM controller they proposed, we still have some reasonable throughput, and then maintaining the standard, KPI for the user workload. So what we are saying in effect is that if we have so many people, accessing their advanced metering system or their smart meters from their remote location, we have a very significant tendency that traffic, or what they call it, traffic access from their account will suffer less degradation. The throughput is quite significant. So we have been able to build the application, the Enterprise Energy Analytics Cloud Portal, that rests and sits on the cloud environment. Actually, this application, runs on the mobile device. Users can be able to select their meters, select their number, select their location, and then load their load profile, and then be able to see exactly their consumption detail right from the comfort of their homes. So you can load your profile and then assess your consumption profile, and then you can even do demand side management right from the comfort of your home. So you can select your consumption profile per day, per month, per year. You look at the cost and you can view your summary. And then below you can see the analytics that is generated for the audit view for the metering application. So power consumption for a particular month, you can be able to assess it. You can be able to do your demand side management. You can shut down the meter, you can start it up, and then you can be able to view assets. So the prototype have been done. We are looking at working with some vendors to be able to commercialize this project. In fact, as I'm talking to us now, we are working on partnering with some companies that will help us to mass produce this metering system, because this is one of the biggest problems we're having here in Nigeria, the issue of metering to enable the consumers actually participate in the grid transaction. So this discussion is still ongoing, and in the shortest period of time, we intend to go into mass production and their deployment. So the prototype have been developed, I've tested it, and they are fully working, and then we can be able to monitor them. So in conclusion, we are making strong advocacy for re-engineering of microgrid energy systems within the smart grid ecosystem as well, bringing in the different components of the renewable energy system. The cloud integration should be able to support the Enterprise Energy Analytic Cloud Portal for tracking the end user profile. And then this must be compliant with the ISO standard 14005 5001 ISO standards, because most of the system people have built in the past never consider some of the environmental factors that will lead to energy temperature drop. We have been able to look at the standard and integrate it into our overall grid infrastructure. And then when we carried out the statistical survey tests,
Hello, Kennedy.
I think he disconnected.
Yes.
Should we go on? Or wait?
Yes, I think should.
Yeah.
Is any author is remaining for this session? I don't think so.
I don't think so. I think it's going. We're almost at SEPA 7 right now.
Yes. We have still 10 minutes, right?
Yes, 10 minutes.
The presentation was okay.
SEPA 7.
Hello?
Hello?
Hello.
Hello?
Yes,
Yes,
and
this is
hello.
Gabriel. Can I present?
You're too low. We can't hear you.
Hello? Can you hear me there?
We can't hear you clearly.
Oh, you can't hear me clearly? Can you hear me now?
A bit better.
Yeah.
I can hear you. Can you hear me now?
Yes, now we can.
Better now, yes.
Okay. May I go on, please?
Who are you? I don't know.
Identify yourself, please. Excuse me, sir. Can you identify yourself,
Yes,
please?
hello.
Maybe he disconnected, I guess.
Meanwhile, Gabriel Arome says that he is ready to present his work on two layers
Yeah,
to
I think he is presenting. He is the guy who is talking.
Yes, it was a guy who was talking.
probably,
I'm
yes.
trying to find
This network is so bad. Why?
on what session he is. Oh, he was from SEPA 5 at
He's the
9,
first
10.
session, yes, in the morning, but they were all sleeping, you know.
Yes.
I called him several times and I connected him, sent him the text message.
Hello?
Okay.
Can you hear me?
Gabriel, please present. We have only 7 minutes to start the next session.
Okay. Please,
I'm
can you
not
see my
sure.
screen?
Oh, he's connected again. Gabriel,
You see my screen?
your sound is too low. Please speak louder.
Can you see my screen now?
Not yet.
Oh.
I think that in order to share your presentation, you have to enable the video.
The video?
Yeah, your camera.
Okay.
Gabriel. Hello.
Yes, I think we should start. Still, we have 6 minutes. Gabriel is lost.
He lost connection and I think he entered again, I guess.
Because we have only 5 minutes.
No, it's connected again. Yes, in the meantime, let's check who is from SEPA 7. The presenters from SEPA 7, please identify yourself. Anybody from CEPA 7?
Yes, I am Esteban Gomez from CEPA 7.
Elham for CEPA 7.
Yes.
Oh, first one, please. First come first.
Solitos and Taiwan.
It is not that. It is
Presenter
CEPA.
3 for CEPA 7.
Sorry?
Okay.
Presenter 3.
Okay. So,
Not presenter for CEPA 7.
okay, thank you. The presenter of 11 o'clock is here.
Hello.
Gabriel.
Is Fernando Gradio is there?
Yes, sir.
Fernando.
Fernando Garrido.
Fernando. Is Fernando there?
No, I don't think so. Esteban is here. Esteban?
Yes.
Okay.
I'm ready.
Okay, so what do you think, Professor? Do we start with Esteban? Or wait a little bit?
Fernando is there?
No,
Fernando is there? So
He's
Stephen
not.
is there, right?
Stephen is.
CEPA 7. Stephen is there. Abu Salam is also. Oluto Sintayo is there. Thais is there.
Thais Weber is there.
I think all of the in 3 sessions, one presentation is missing, right?
Yes, Professor.
And we are leaving. At what time you have to leave today?
I have to go out. Let me check here because I need to do some conversion.
Is after CEPA 8 or after this one?
I can be here till just a moment. I have to leave here at 8 o'clock in Brazil, so I can be here till
Next 2 hours.
yeah, till 1 p.m. right?
Okay, so next 3 hours you will be here.
Yes, I can be here.
2 hours.
I can be here till 1 p.m. Now it's
11.
11. Yeah, 2 hours.
Hi, Prof. It's Jay here. If you need me, I'm still here.
It's okay. I saw you. Thank you so much. Just to be present with me, okay? You are 2 of you are my left hand, right hand.
Thank you.
I'll be here.
I'm confident I saw you in the morning. So ask to all the audience, please on your webcam. So we can also take some pictures from your screenshot. All the authors, please, on your webcam.
Let me take a picture again.
No, but yes, please on your webcam. There are several. They are still off. Andrea is there. Andrea, why you
Prof, I'm
are
greeting
offering?
you.
It's okay.
Ah,
You are again
This
there.
Kennedy is
Yes,
greeting you.
right. Thank you. Please on your cam so we can have a screenshot. I have taken. Yes, you can also take these pictures because this is a group picture in the last session.
okay.
Right. Moderator, you should be there always in the group pictures. It's okay. Please present. Next presenter.
Okay,
Next
Esteban.
presenter. Yes. Ask to present.
Esteban.
It is already 10.
Yes, he was.
He was there, right?
Yes, yes.
Well, should I start?
Yes.
Yes, start. It is already 10.
Yeah.
Okay. Let me start. Okay, I'm going to start.
Yes. Steven is there?
Yes, Steven Gomez.
Yes, Steven. Go ahead.
Go ahead.
Steven, start.
Okay.
Share your slides. Go for the yes.
Okay. Good morning, anyone. I'm going to present towards a new perspective of building tools for context-aware mobile applications. Our outline is the following: motivation, objective, variability concepts used to design our tool, our building tools for context-aware mobile applications, discussion, and conclusion and future works. Technological growth has allowed several characteristics in context-aware mobile applications, such as the use of sensors, geolocalization, cameras, and intelligent transportation. Consequently, there is an increasing demand in the market of mobile applications. This is a complex task. It's not an easy way. So, building approaches appear for expert and non-expert user. Unfortunately, the approaches don't support variability in order to generate applications. Our objective: designing a building tool for mobile application address to support variability by using a taxonomy of factors. This is based on UML standards to give interoperability with other existing tools. A discussion is presented how to consider the variability to generate a wide variety of applications. We present a variability concept used to design our tool. We have to consider a building approaches for context-aware mobile applications. So we have classified in the following: relevance, each context feature that has its own relevance in each application. For some applications, some of them are critical, others are optional. Combination, the way how contexts could be combined one to each other. Precision and accuracy is related to the sense of how we can set up. Categorization, the way how we can classify. The type of configuration is again related with sensors, cameras, and so on, and we can set up to in passive or active mode. Type of execution, it could be also in passive or active mode. Here we have the variability concept used to design our tool. First of all, we have an aware object. An aware object has a context feature. A context feature can have category with a wide range of values and relevance with a different kind of values. After that, we have, this is a basic context concept. We have an abstract sensor who has abstract sensor and the classification with sensor type. Then we have the concrete sensor concepts in this right. The concrete sensor could have an execution type and configuration type, and also a margin precision. And also we have here the rules. The rules can observe the context feature, can update, and also can trigger some services. Our building tools is based on an integrated system of Eclipse development environment and series of view to represent each concept using a visual DSL. Also, we interact with JBoss in order to generate automatically the mobile applications based on this concept that we have expressed. So we have an e-core meta model which generates a visual DSL with a series of view by using model-to-model transformations and model-to-text transformation. So we have this concept, and for that purpose, we have designed our building tools for mobile context-aware applications. What is this? This is a representation of how the user can manage the visual DSL in order to simplify and in an easy way to conform the base of building the construction for context-aware mobile applications. After that, we have a discussion. There are some points to consider regarding building approaches. So, based on building approach, we decoupling basic concepts. So, our tool provides meta models with basic context-aware concepts in order to have the first level of variability. Also, we generate application by using the information of basic context-aware and variability concepts. After that, we have set up Eclipse, JBoss, and the interaction between plugins have the possibility to conform an integrated system to generate the applications. So the combination of concepts implies to define the heuristics to specify how it behaves when they are combined each other. Also, we have, once again, the Eclipse and JBoss plugins, and we can generate another plugins also depend upon the necessity. Choice of the appropriate development environment to design a building tool is important. Conclusion and future works. This paper has proposed a building tool to support variability for the next generation of application, designed using the taxonomy of variability concept that we have expressed. Also, a discussion and analysis are presented with recommendations that should be considered to select the appropriate development environment for designing building tools for context-aware mobile application. We continue working to improve our tool to provide automatic generation for mobile applications. We will analyze other variability features to enrich our building tool. Thank you very much.
Thank you, Stephen, for your presentation. Any questions? I have one. How do you evaluate your work? Because it seems that you automatically generate the application, right?
Yes.
But do you have some proof of concept or something to show an application generated by you too?
Yes, we have been working with several proof of concepts in order to set up and adjust to requirements of the different users. So we are going to also send to different users in order to have the validation of different characteristics and setup. And also we are going to include another layer, including HTML, CSS, and JavaScript in order to facilitate this kind of proof of concept.
Okay, thank you. Okay.
Ismail, I have a question.
Okay, Jay, please.
It is very interesting concept. I'd like to know, how do you translate from a use case into some aspect that is generated, that the code is going to be generated from?
Well, we have several ways. We have one of them is model to text transformation by using Xtext, and the other is using Axeleo. Axeleo is one of the plugins that we have Eclipse, and we can use setup, and easily it's based on templates, and we can transform it from model to text or from text to text generation. It depends upon the necessity.
Okay, thank you.
Okay, thank you very much.
Okay, thank you very much. So let's go to the next presenter. Abda. I think the next presenter. I'm sorry, I don't know how to pronounce this name. Abdullah.
Yes.
Abdullah.
Absalam.
Yes.
Ulwa Tosin tayo. Ulwa Tosin tayo.
Hello, good morning.
Hello.
Yes.
Yes, I'm here.
Ulwa Tosin is there, okay? Yes.
Yeah, good morning.
Good morning.
Good morning.
Yeah, share your screen and present your work.
Yeah, I'm presenting. All right.
Oh, to see. Okay.
Good morning. I'm Olutosin Taiwo, and I'm presenting paper titled Smart Home Automation System using Zigbee, Bluetooth, and Arduino technologies. Here are this presentation outline, and I'll move straight to used in the course of the paper. And the first thing is a smart home. When we talk about a smart home is a residence incorporating communication networks which connect major appliances in the home, such as fridge, bulbs, lights, together, so that they will be monitored, accessed, and controlled from any location where one is, within or without the home premises. Then we talk about smart home automation system. This connects controlled devices into home to a central hub. This means the smart home automation system is the means of integrating everything together as a network so that the control will be so easy. The main objectives of this paper, or of a good or of a smart home, as related to this paper, as scalability. When we talk about scalability, is the ability of a system to accommodate additional devices. For instance, you've purchased a new device, you want to add it to existing device. Any smart home automation system design must be able to accommodate more devices. Then interoperability, the ability or capability of a system to efficiently interact with other devices reciprocally. Then efficient control and monitoring, ability to control appliances and devices in a home from any location, no matter where you are, maybe in the office, in the market, or anywhere. You forgot to put on your light, you can switch it off from wherever you are. So the motivation for this work actually is ease and convenience, to provide ease and convenience to home users or homeowners, and to provide them security of their home from wherever they are. So in recent times, most of developed smart home systems are used to provide ease to users, as I said earlier on, so as to be able to control home from wherever one is. So as a result, the work is motivated by ability to control, to manage, and to use home, convenience and ease of access to the home. And there are some questions we try to solve in the course of doing the work, which are: how much can home be successfully controlled from outside its premises? Then how can the limitation of short communication range, that is, if I'm not within my own premises, I'm outside the communication range, how can it be overcome? Then how can user add additional home appliances to application without having difficulty? So these are the problems we tried to itemize so as to solve. So for this, in order to solve the problem highlighted, we designed a method that combines Zigbee and Bluetooth together for wider communication range. And we tested the proposed work, because it's still under study and is still in progress, with a simulation software to know the feasibility of the study. So looking at the related works, we have so many related works, but in brief, we have Wahab et al. That presented design and implementation of smart home. These are their function, the technologies used, and their focus. We have Hamza et al. Then we have Paul et al. As well, the focus, the function, and the technologies used. So I move straight to the design methodology. For the methodology of this home automation system, we have majorly two parts: the hardware and the software part. The hardware part talks about the hardware technologies used, the board, the physical components of the system, the board, the Zigbee module, the Bluetooth module, and the smartphone for control of the home. Then we have the software components, which are the developed side, the applications. So for the hardware parts, we use the Arduino board to function as really digital pins from the system, then to monitor, so as to serve as a motor for activating and deactivating. Then we use this Arduino board in the Proteus to test the visibility as well. Another hardware used is the Bluetooth module. The Bluetooth module serves as communication. It serves a dual work in the work. I'll still explain more when we get to the part. As an interface with the board, the Arduino board, and the microcontroller. Then also the smartphone as well as a Bluetooth module. Then we have the Zigbee. Zigbee is connected and paired with Bluetooth for wider communication range in the methodology. So for the software part, we have the mobile application, which was designed with an Android-based smartphone application, and it is based on Java integrated development environment. Then we have the IDE for the Arduino board, which the codes were written in C. So in order to address the issue of the interoperability and scalability in the statement, the proposed home system is modeled to be convenient, low cost, and for home control. That is the activation of home appliances. So the proposed system is divided into 3 major bases. And when we talk about this, we have the sensor-based appliances, we have the non-sensor-based appliances, and we have the smart home technologies. The sensor-based appliances, for instance, now we want to open the door. That means the door needs a sensor to be able to communicate with the controller. So the non-sensor-based are things like the microwave, the fridge, which might not actually need a sensor to operate. Then we have the smart home technologies, the Arduino board, the microcontroller, the Bluetooth, the Zigbee. So the sensor-based appliances are interfaced with the Zigbee module for communication with the board to enable better communication and control of our appliances. Then Zigbee is combined with Bluetooth, as I've explained earlier on, for wider communication range. Then for communication of home appliances with each other, the Arduino board, the Zigbee, and the Bluetooth module are interfaced together, and the home appliances are now connected to the. So to test the visibility, because we are still in the aspects of the physical experimentation, we tested the communication using Proteus to control light. So this shows the visibility that Arduino board can actually communicate with LEDs in the home, and our LEDs here represent the fan, the bulbs, and switches. So a mobile device with the installed mobile application was developed. A mobile application was developed, and the mobile application communicates through Bluetooth with the home. So the figures below shows the interface of the module. Now, before the user can communicate for a bit of security, he or she has to authenticate using a passcode, which is only known to him or her, to authenticate before actually using the app. So this shows after the login, after authentication, after the login, then if one is signed in to control the applications, then the figure C shows the connection between the Bluetooth and the controller. Once the connection is created, then the interface of the control of devices can be authenticated. So in conclusion, we try to present a system for home controlling of devices and applications from any location with an hybrid technique based on Android application, the Bluetooth, the Arduino board, and Zigbee module for communication, and also an initial cost evaluation reveals that the proposed work is cost effective, as we are planning that we don't want to buy new home appliances. We're trying to integrate existing home appliances for the work in order to reduce the cost, so that if is implemented and deployed into the physical world, it won't be that the users will have to purchase sets of new appliances in order to be able to use our system. So for the future work, the next stage is actually the physical connection of the components and the control of the home from a far range. So these are the work we've done, and we also plan to extend the work so as to be used for the handicapped and the elderly, and those that can't be able to move very well within the home premises as well, not only outside the home.
Okay, thank you very
Thank
much
you.
for your presentation. Any questions?
I have one question.
I have question.
Okay, please identify yourself.
Jay.
Adeni
Okay,
Manuel.
please, Jay, go first and then the other one.
Okay, thank you. What I'd like to know is, I assume that you are not connecting from the internet into your application. So at the moment, it is just via the local Bluetooth network. Is that correct?
Yes, sir.
Okay, all right, thank you. So what is your plan to connect from the internet? So you would need an internet gateway, I would assume.
Yeah, we will need an internet because when you are outside the home, for it to communicate, it has to be deployed using internet. It has to be based on the internet. So we plan incorporating that in the next phase of the work to see the network range and how the data variability will look like and things like that. So the physical, when deploying the physical aspect of the work, those will be put into consideration.
Okay, thank you very much. Thanks, Etamir.
Thank you,
Thank
Jay.
you.
We had other question.
Okay. What a nice presentation. Part of my question is the cost. You said the app is cost effective, right? Like how much when we relate, if we relate it to Nigeria price. Then secondly, the app is connected through Bluetooth, and we know that the range of Bluetooth is just as less than 10 feet or 33 feet.
Very short.
Yes, it means that your control is still within the vicinity of the environment of the house. That is, you can't go beyond that. Once you go beyond,
Yes.
for instance, if I want to travel for like 100 meter, that is, I can't have access to my to my home again. What can
Yeah.
I or what can we do in
To the
order to
home.
make it global? Like you can travel like 100 meter and you still have access to your home. Then another thing is you said you develop a mobile app using you from Java platform. Is the app is it going to be compatible with other um, OS like iOS and iPhone, or is it limited to Java phone alone or Android? Thank you.
Thank you. For your first question concerning the communication range, the Bluetooth has a shorter communication range because it's still a work in progress. That's where we are combining Zigbee with Bluetooth to address wider communication range protocol so that we'll be able to control from a far distance. So we are planning to combine Zigbee with Bluetooth. So for now, in order to communicate with the home, that's why we are still making use of Bluetooth to establish the feasibility of the system. Then you talk about the cost effectiveness of the system. Concerning the mobile application, we are still considering the cost effectiveness for that, but the establishment of the cost effectiveness in this case is, we have so many smart home automation system now. An example is Alexa. So, and there are some appliances that cannot communicate with some home system, that whereby you have to purchase new appliances. So those are the gaps we are trying to bridge, so that if you have existing microwave in your home, you won't need to purchase a new one in order to make the system we are trying to develop communicate with your home appliances. I don't know if you get what I'm trying to say.
Yes, I'm
So those are
getting.
the considerations we are. Yeah, so that's the area we are incorporating the cost effectiveness too. So that's why we talk about sensors, that even if you have to purchase some new things to the home, it will be minimal things like sensors that will be integrated to the existing home appliances. Then for the deployment of the mobile application, if we say we want to limit it to only Android, that means we are being backward in our work. So we are trying to extend it to several platforms, not only Android operating system. It can accommodate the iOS and other operating system, because if we base it only on Android, that means we don't want it to go too far. I hope I've addressed your questions.
Yeah, thank you, ma'am.
You're welcome, sir.
Thank you very much. So we have now Thais Weber, right?
Hi.
Hi. You were on time, so.
Yes, I'll try to share my presentation.
Okay, thank you.
Gabriel, please remove your screen. Azim Thais is going to present the paper, right?
Yes, Professor.
You are seeing my presentation?
Yes.
Yes, yes.
Yes. Okay. So I'm Thais Weber. I'm from University of St. Andrews, and I'm presenting the paper Designing a Patient-Centric System for Secure Exchanges of Medical Data. One of the challenges of modern healthcare system design is to put the patient at the center of his healthcare provision, which means that patients should be able to decide who and when, for example, professionals or organizations can have access to his medical records. At the same time, the system must comply with data protection laws, such as the European GDPR, that provides regulations to exchange personal data. We consider three perspectives then for system design. First, we propose a multinational integration of medical records, proposing a unified format to integrate them. Also, this data integration needs to consider security aspects, such as privacy and confidentiality, to allow the secure access of these patient records. We also propose blending systems and technologies, like using blockchain, mostly for data access control, and data warehousing approach to efficiently retrieve the integrated medical data. So modern healthcare systems must be able to collect, store, and integrate medical data from different sources and formats, and also run safe authorization mechanisms to access these records. And further, in the future, they should be able to integrate algorithms to perform data analysis or complex predictions for patient care. The case study we present in this paper is part of the Serums project, which is an European Union funded project. We combine the expertise of 9 institutions, as we pointed out in the slide, in 7 different countries. So it is certainly an example of global software engineering application. And the goal to achieve our goal, which is to put patients at the center of future healthcare provision, enhancing personal care and the quality of treatment, we aim to integrate emerging technologies. And to do that, we need to establish phases and activities in the process, in the software development process. So we proposed a design workflow to do that. Here is our architectural design workflow. We created this workflow as a way to facilitate the central system integration. Our workflow was defined considering traditional phases of global software development, such as inception phase, elaboration, construction, and transition phase. In the inception phase, our teams worked defining work packages, high-level requirements of the project, and we also set up an information sharing repository. In the elaboration phase, which is the focus of our paper, teams collaborate to design beautiful artifacts that can ease the integration task in the construction phase. So several activities take place here in this phase. We have the development design composed of context definition activity, functional design, information flow definition, concurrency design, deployment design, operational design. So we have these activities performed somewhat in parallel, but sometimes in a sequential manner, since teams are working dispersed throughout their locations. And After elaboration phase is done, teams will follow to the construction phase, which is the development per se. And after that, our project will move to the transition phase, which is when the system goes to production environment, so we can perform evaluations with our stakeholders, users, and our most important user, the patients. So I brought here an example of artifact we produced, the context viewpoint. It captures the interaction of the system with users and external systems. We show here 3 categories of users. We have patient, hospital administrator, healthcare professionals such as doctors, nurses, and so on. We also map actions and response from our central system. So 2 important actions we have here is, for example, the management of access permission through the system, and also the request for medical records. Patients can request to see their own medical records, as well as healthcare professionals can request patients' records to visualize if they have privilege to see. So we also depict here, we have external users like hospitals or organizations. They are supposed to connect to the Serum Central team through standardized APIs. And we also can have in the future health tracking devices. They could be able to transfer medical data if patient agrees to that, through also standardized APIs. So this viewpoint, it shows important functionalities of the system, shows the most important users, and sister interactions needed to get the functional viewpoint implemented. So here we brought the functional viewpoint. It translates the requirements into implementation models. We show here the integration model with 2 subsystems, the front end, our front end that will deal with user interface and user requests in the system, and the back end component that interfaces and coordinates other models, such as authentication model, authorization, data processing model, to get responses interoperating through APIs. We also have external interactions. Here, we put an example like hospitals communicating with the system. Also, this can be performed through specified APIs. Another viewpoint is the information flow. It shows the information flow throughout the system to achieve the main functionalities of the system. So we have here the responsibilities of each model. Each lane contains a module, for example, web browser, the integration model, authorization, and so on. So the three models show their responsibilities within the whole information flow. This is a very rich artifact. As we can see, we can have many information depicted, and it's very easy to go to the construction phase when you have a clear detail of the information flow in your system. Here is the second contribution of our paper. From the requirements specification, we narrowed down 5 important quality attributes for the integrated system. We emphasize that attributes can be reinforced by specific viewpoints. So we have compliance, where the system is in accordance with laws and regulations, which are determined earlier on requirements specification. We also have traceability and auditability as a quality attribute, which is the ability to collect data about transactions and record user access. So we have information flow here. It is the most important viewpoint, shows that, for example, our authorization layers will include logging the entries in the system, and the functional viewpoint and the context viewpoint also a way to, for example, capture which actions should be logged. So this way we can achieve traceability and auditability. Testability in our context is related to which degree a software artifact can support testing activity in the development process. So can be ability acquired by viewpoints, in our view, to support the testing phase. Interoperability is how we can define the interfaces for secure data exchange. So many viewpoints can individually to highlight this non-functional characteristic. As well as for each attribute, we identified potential in each viewpoint to reinforce the requirements to achieve these non-functional requirements. So I brought some of our key points and observations of the design phase. From requirements, informal discussions among teams, we saw that often they resulted in rework and misalignment of activities. So our modular decomposition in the design help us producing more focused artifacts, which is now very useful in the construction phase. Also, the functional viewpoint granularity, we see that this granularity can vary depending on the perspective or responsibility of a development team. So sometimes we need additional support diagrams to depict the functional viewpoint. So it's a very useful activity design workflow. Also, the approach we chose for interoperability was the containerization. So we package our system and all its dependencies together in the form of containers to run seamlessly in any environment, in the development environment, test environment, further in the production environment. And also the information flow viewpoint. This is definitely the richest artifact to understand the model's interfaces, data exchanges needed in the system, and also the security steps demanded by our application. So it demonstrated to be an essential viewpoint to highlight several quality attributes. As a conclusion and some final remarks, I can say that as any global software development case study, our project has several challenges regarding the issues coming from distributed teams. So we have multiple communication channels to coordinate. We have issues in requirements alignment. So our architectural design workflow was a way of delivering significant artifacts for development iterations. Our aim proposing the design workflow was to help stakeholders make design decisions that impact the system integration. So these impacts are first understood in the elaboration phase, when the system architecture can still be prone to change. If these potential issues for integration are detected and dealt with in this early stage, we know for a fact that the construction phase will follow a smooth development. Our experience shows that in data integration projects, such as serums, system architects, developers, and all people involved in the project can profit from designed viewpoints as artifacts to review integration challenges and also to highlight desired attributes. So thank you for your time, and I'm open for questions. More information about our project can be found on the website, and we also have a Twitter account to posting our latest news. So thank you very much for the opportunity of being here.
Thank you, Thais, for your presentation. Any questions? I have one. Thais, I saw that your work's a very complete work. As we can see, they using a big project. I was searching for this project here. But tell me, what's actually the you have some related works, right? About your designing patient-centric system. So what's the difference from your approach related to the other ones?
So our approach is try to integrate emerging technologies, blockchain and that data warehousing in such a way that the integration can be easily conducted. Related works used cloud computing, used many things, but didn't exploit the fact that in such big projects, we need to have a process, a design process, well-defined to cope with issues before the construction and before the deployment, so we have less issues after deployment of the system. So our contribution is basically to provide this workflow for design, pointing out that viewpoints can actually help the integration, and also if you think in a system that will help patients, which is a patient-centric system, we need to be sure that the quality attributes we put on the requirements, they are actually met. So our challenge now is to go to the construction phase, putting in practice all the viewpoints we have been discussing throughout these months. So this is the difference. I mean, could be the proposal of a design well-structured, design workflow well-structured, and combine these designs with refinements to put quality attributes inside the viewpoints.
Okay.
Is it a part of your PhD work, or it is a project under which you are working as a researcher?
I'm a research fellow in this project, and
okay.
I'm working since December in this project. It started 8 months earlier, but when I arrived at the project, I started to think that having this workflow, this design workflow well defined, having teams on board in that process, we started to have more results and more artifacts produced by the teams. It's very difficult to work with several teams like that. We have 7 countries involved. We have cultural differences. We have time frame difference sometimes. So it was very important to produce this design workflow and everybody following and on board of this.
Okay, it is nice work. And before coming to the UK, you was working. Are you the British, or you are from anywhere else?
Oh, I am Brazilian. I'm from Brazil. I arrived in the UK in August last year, and over there I was a lecturer in computer science. I worked mostly with software engineering, but non-functional requirements. So
Non-functional environment.
Yeah.
Very nice, because this is my area of research as well, medical informatics. My friend is working in the medical informatics, so that's why I gave him the opportunity to share and also ask, improve the knowledge and sharing the research as well. Nice. I hope that you are going to present the next work of the same project in the ICCSA 2021.
Oh,
right?
that would be nice.
Yes. So we hope that you will have the more results for the presentation, and it was really a nice presentation as well. So it was a good time to see your works, and it's okay. Mm. Any other presenter is there? I think it is the last.
Sorry, Jamil, can I pose a question?
Yes, yes,
Oh,
why
yeah.
not?
Okay, please.
All right, okay, thanks. I have two questions. One is if an institution or someone wants to take this model forward to build an information system for patient or HIS for hospital information systems, is there any copyright or what is the process going forward? That's the first question. And two is
Actually, the research is open to other
open.
applications to apply and see what comes from it. It will be a pleasure if anyone wants to use our design workflow, our ideas of combining these viewpoints with quality attributes, and see if they can have a successful deployment of their project. So there will
Okay.
copyright involved, but
Okay.
we reinforce that we can cite our paper, so it's good for us.
Sure. All right. No, thanks for that. The second question is there any possibility of using this to teach students in project work?
I guess it could be an easy way to PhD students or other researchers or system architects to have a more clear view of their requirements and the issues that can come from integration projects such as Serums. Serums is a data integration project. So the information flow viewpoint was the most important diagram for us because we are dealing with data integration and the data flow is important.
Data.
But
Okay, thank you.
every other viewpoint can be used and for different projects and objectives.
Thank
In
you.
absence of any question, I think there is no any presenter now, right? So we have 5 to 7
Yes.
seconds, 7 more minutes before starting to the next session, right? Thais, you need to ask anything from us?
No, that's, I just want to thank you the opportunity of being here and thank you.
You are welcome to again and again to this conference, okay? This is a software engineering platform and I don't know why you have not attended yesterday. There was very good papers on software. In fact, the first paper in the requirement engineering was presented in the first paper today, right? This was on the requirement engineering.
Mm-hmm. Okay, Professor. I'm sorry, Professor. I guess I lost the last.
Yes, no. I am saying that the first paper for today was presented a framework of the agile software development, service-oriented architecture, and quality assurance. So this was also a very interesting paper in the morning.
Yes.
We are moving towards to the session 8, right?
Mm-hmm.
Session 8.
Session 8, 12 o'clock.
12 o'clock. Yes, it is only 5 minutes are remaining, right?
Yes.
So I don't know that several authors. Mm-hmm.
I don't know if there is any.
How many presenters from the next? I can see in the next presentation. No, Sama is there.
Sama. 12:10. Yes, he's there.
SEPA 8. Please ask that if anybody is remaining who want to present now, and any of the existing authors, audience who need to present his paper, missing paper from the back.
I don't know if that Angelo, I guess, what's his name? He's trying to present.
Yes. Is he there?
I don't think so. Let me see here. No, he's
Yes,
not.
Niranjan Lal, you can also present your paper now. Niranjan.
Yes, yes, sir. Good afternoon.
Yeah, you can present your work now.
I can present. Okay. So, share my screen.
Yes, just to introduce that when your paper was scheduled and who you are, and inform to the chair.
Yes, sir. I Dr. Niranjan Lal. Actually, my session was yesterday.
Okay.
In
What's your paper title?
yeah,
It was in TDSGP.
yeah, DDSCB. But actually, due to I was not at home or in my office, so that's why I missed my presentation yesterday. So I have requested Sanjay Mishra sir to present today. If there is any possibility, then I can continue right now, sir.
Okay, please present. Niranjan, a proposed ranked clustering approach.
Yes, sir.
Okay.
Hello.
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 Hello. Yes, go ahead.
Yes, sir. My presentation is. Sir, my
Go
PPT.
ahead.
Hello.
Yes, we
Go
can
ahead,
see your
please go
presentation.
ahead.
Go ahead.
Okay. Good afternoon, sir. Actually, I am going to present my topic. This a proposed ranked clustering approach for unstructured data from data space using vector space model. Actually, this research paper is under my project. Okay, handling a one project under the collaborative research stream by the AICT New Delhi, India. Okay, so I am as a co-PI in this project, and we are working from last 29 2019, 2019, and this is 1 year project, and it's going to be over in this year only. So there are some content I have designed. It's just I'm going to discuss about the introduction, some material management, and the conclusion, and some references that I have included in my paper. Okay, so basically, first. Uh, information retrieval is related to, actually we are working on a project that is just like a research gate. There is a research gate we everyone know we are using nowadays. So this research gate is actually there are some issues, but that research gate type a framework we want to introduce in our college and universities. So we have submitted this proposal to AICT, and AICT India, they have accepted, and then we are working from last 2019. So actually, this is a simple diagram of information retrieval. We everyone know this is a query, just like a search engine. We are using a Google and some other search engines. So here, just we have to use the unstructured data. In our paper, in our research, we have included unstructured data. There are many type of data available, just like structure, semi-structure, unstructured, but we have chosen only unstructured data, because in case of unstructured data, research gate is mainly based on a document, just like a doc file, sometimes the PDF. So we have selected this. So in this case, we are using one term that is a broader area of the database. It's a data space, basically. Data space, actually, it's provided just like in a database. We need, if you are storing some data on database, there are different one type of data. So for heterogeneous data, just like unstructured data, semi-structured data, and uh, structured data. We have to use a different platform and different framework, just like so. But in case of data space, it provide a one how to handle the heterogeneous data. If we can here there are this is a one layer. This is called data space layer. Here we can store all type of data in ds1 data space one. We can keep a ppt. In this we can keep a pdf file. Here we can keep some text data, social media data. We can keep some images. Here we can keep some audio and video. And there is some legacy data also. It's a legacy data is nothing. It's just historical data. Just in organization there is all data is available, but how to fetch that legacy data? Just there is an interface. So by using our platform we can also access the legacy data. So we are also providing one interface to manage, query, and fetching all data from the legacy system. There is a middle layer. This layer is called service layer. Actually, this is the heart of the data space layer. It keep everything related to the data space or data. There is a catalog and browse, how to store, what are the data type we have to use, and then how to index them, what is the work, how to search, and how to apply the query on a different database research relational databases, WSD and XML data, sensor data, all type of data we can store in case of a data space. So next, there is a requirement of the data. There is a need of data space basically in all the enterprises and an organization. How to handle the heterogeneity basically. And then if there is a heterogeneous data is available on a different department, just like if there are department, one is computer science department, another is mechanical department, and then third one is electronics. All these three departments are handling their data. They are storing in a different way. One are using Excel sheet. Computer science is using some database types as MySQL, SQL, MS SQL. But mechanical department again using a document. But at the end of account department need to calculate the salary of all the faculty, all the staff member. So there is a requirement. They have to convert in a one format, homogeneous to heterogeneous format. In homogeneous format, then they will calculate the salary of each one. So there is a requirement of there is a different type of data available in a different format, in a different size, and a different way. So actually there is a problem statement we have find out in our project. This is how to store the unstructured data in a data space, and how we rank them, and how we can index and rank, and how efficiently we can retrieve the data from the data spaces. So the third one, if how can result consisting of structure, semi-structure, unstructured, and heterogeneous data is the combine. Basically heterogeneous means we can combine all these three data. And finally, how unstructured data is productive daily by digital world, because nowadays the unstructured data is increasing day by day in an organization, enterprise, and company, and even on our mobile phones. So actually the main contribution in this research paper, we have created one framework for clustering by using a clustering approach. Because clustering, we are using a clustering approach in our research paper, because we will cluster our different type of data. If you are using a PPT, then we will keep in one thing. If you are using a PDF file, we are using a socially streamed data. So we will try to make them in a cluster, so that will be easy to retrieve the result, and we will get the better result out of heterogeneous data. Secondly, we have proposed a one rank model. It's using a vector space model. It's already existing approach we are using in our research paper. And then we have applied a one modified vector space model. By using modified vector space model, it's giving a better indexing, better uploading time, better indexing, and within a second it also retrieving the result of any query. It's a simple vector of vector. In this case, there are three terms we are using. One is term. Term is basically it's any word available in a document. There is a document and then query. So it's a simple formula for calculating the how to calculate the term frequency. It's a number of times the keyword appear in the particular document, and it's divided by total number of keyword in the document. Then we can calculate the term frequency from the document. It's a simple formula for calculating the IDF. It's inverse document frequency. It when we will apply the query, then we have to multiply for calculating the term frequency inverse document frequency of the document and query. Then we will multiply. Then we will calculate the TF IDF by using. There is a simple example we can use. It says a wheezing duck receiving cat food. So we can find out similar word in this, but in our we have used 12 document for calculating the cosine similarity by using there is a actually I'm just going to the final proposed approach. It's a diagram. It's a simple approach that we are using. It's combine the data space in database. There are three layers, but we have here we are using a modify approach for our for better results. So here there are different. So mainly our approach is working here in this inverse document frequency vector space model. The internal structure of this IDF vector space model is here. Basically, it's containing a different type of. Here we are clustering just like a document picture. We are seeing a document, and then PDF sign, then XML, HTML. These are the different type of data, and then we are clustering in a one cluster. Cluster is a similar type of just like document, text, HTML, and other type of data. So here just we are applying a text analysis because it's basically unstructured data. Then we are not using any image or video in our research work. Basically, it's just related to text and document. Then we are using this. So it's a complete model we are using. Here we are applying our proposed formula that is a modify vector space model. Just I'm going to showing the formula next. These are the final steps of our project. Here we are analyzing the data. First step is data source analysis that contain how to store the data, how to index, then what type of stop word we have to remove, how to stream of word, means how to remove unusual word from the document. So there is no requirement of searching. Then we are applying the vector space representation of unstructured document. Then there is a final modify formula. It's contain it's a modify of vector space model basically. And then next there is a we have done the indexing of unstructured data. In our research project, we also use the Apache for indexing purpose, because we cannot use anything with the SQL or MySQL. That's why we have used the Apache Hadoop for indexing of unstructured document. So we have indexed our document by using the Apache Hadoop. And then we have the clustering, and there is a simple formula.
Come on the conclusion, please. Come on the conclusion, Niranjan. We are shooting over time. Okay.
Okay. So in conclusion, actually, we have used some document, and then here by using the traditional approach and our modify approach. So the cosine similarity is showing better as compared to the traditional for the same document. And in the last column, there is a sorting of our document is shown, giving the better result. These are the bibliography, and thank you. Any query are welcome.
Okay, thank you very much. Any questions? So I think because of the time, we can pass to Sama. Sama is here, right?
Yes, I'm here, sir. Yes,
Okay,
sir.
now it's your time. Please share your screen.
Since morning, she's waiting for us.
Yeah.
She went here and there several times, So
No, I am very happy, Doctor. I am very happy.
So are you enjoying the?
Yeah, this is the first conference I attend from I started my PhD.
Okay, so and it is online, right?
Yeah,
No,
online.
next year I will take you physically in the conference.
Promise me. Promise. Promise me.
What?
Promise. Promise me. Promise. I need a promise.
No, I promise, but you don't forget to submit your paper, right? That is the first requirement. And after then, you will apply to your university. You can, or maybe you can visit your country and you can also join to the, okay? Because this is a very good time in the Europe. Right now it is the summer. You can go to the beaches and enjoy the sun bath or something like that. This is a very good time, but unfortunately, we are online meeting to each other, right?
Yes.
Okay. Continue. How you got this conference?
By my supervisor. Supervisors register me in this conference. My
Okay.
supervisor.
Who is your supervisor?
Dr. Rosette Ibrahim. Prof. Rosette
Okay,
Ibrahim.
Rosette Ibrahim. Okay.
Yeah.
Requirement is visitation. It is also with the Thais works is very close to her. His Thais will also enjoy. The guys who are in the software engineering, it is also related to my works. So let us start. Let us see that what Sama is doing in his PhD. Right?
No, it's simple. It's simple. Simple paper, Doctor. Simple.
No problem. Okay. In software, everything is simple. We are not going for the complicated. We are software engineers.
Okay, done. Let's start. My name is Samah Abu Salim. I am from UTHM University. I am PhD student. I will present the paper. The title is Analyzing the Impact of Assessing Requirement Specification on the Software Development Lifecycle. Before I start off my paper, I need to... Okay. Done. You can see my slides?
Now, no.
No?
In the past, yes. In the past, yes.
You can't see my slide.
Yes, we can see.
Now? Okay. Before I need to just make some review or some introduction about what's the SRS, Software Requirements Specification, and what's requirement engineering, and what's SDLC. This some introduction. First, software requirements specification is just a description of the features and services that the system will use or will be confirmed or will be work. What the customer needs in this system. We write this description of the feature and services in the normal document. This document called software requirement specification. Requirement engineering is just a process of gathering, analyzing, documenting, validating, and managing requirements. The main goal of requirement engineering is to clearly understand the customer requirements. What's the customer need from this system? And systemically organize these requirements in the SRS, in the formal document. Okay? Done. Okay.
Okay, I think we lost your presentation screen. Okay, it's back.
Done.
It's back now. I think we lost again.
Yeah, I will share again. Okay.
Maybe if you share your entire screen.
Yes. While your screen is disappearing, we can see your camera is working perfectly.
Yeah. Okay, share this.
Yes.
See now.
Now, now share.
Okay.
You
Yes.
can
Yes,
see.
yes.
Doctor, when I go to next slide, it will unvisible, unvisible down.
Okay, can you see from your end? You can speak, no problem. Because we know all those definitions.
Okay. So
Okay, no,
as
you
okay,
can skip some of the slides.
Okay, software requirement specification is contains a group of activities gathering, analyzing, specifying, and validating users' need. What the user need from this system. We write what the user needs in the formal document. This document written in natural language. All the developers, all the people know this language. The main goal of the SRS is to attempt to fully satisfy users' needs. Therefore, several methods and techniques for SRS development have been used to extract the user's needs, depending on the software complexity. The standard of SRS should have some features like correctness, completeness, consistency, feasibility, and other features. Every feature or each feature has tools, method, and technique. Okay. Now next. So now software development life cycle is a systematic process. This in the development or maintenance of any software product. Okay. This process, the aim of SDLC is to give the detailing the procedure and method used to guide the work of the software development team, which is an essential part of building any software project. Okay. This paper is just a review paper. Not sure.
Sama, just to please do not share the screen. Open the slides in your screen and
Okay.
just speak. We are listening. It will be better. Yes.
You can see my slide now?
Yes, I can see your.
Okay, then okay. This
Go
paper
for
is
your
just a
research
review paper, analyze and discuss all the quality assessment tools and methods used in SRS. We use generic methodology. We do five steps. First step is definition of research questions, and then search for literature review paper, and data extraction and points of interest analysis. And after that, we analyze the data from this literature review, and then result and discussion. The first process or the first step is definition of research question. This research has two questions, or attempt to answer two questions. The first question is, what are the most recent SRS quality assessment methods that the people use? The second question is, what's the impact of SRS quality on a project success and failure of the project? We take the paper from many international journals like ACM, IEEE, Science Direct, Springer, others. The third phase is the use of literature review, data extraction, and points of interest analysis. The main points of interest are identifying the used evaluation method, the most used quality attributes, and the main component of the related model. We just analyzed 12 total papers. The result from the answer of the first question, what's the impact of SRS quality on a project success? And I read many people or many results in the paper, but here I just only show two. The first group find that many projects don't deliver on time, don't deliver on budget, and don't deliver as planned or needed. The main reason for this that many managers of the project don't dedicate the necessary number of staff and resources to the SDLC's different activities. For this reason, some phases of the SDLC are delayed, and other phases are waiting for them to be completed without doing progress. Thus, it creates a gap between the arrival and execution of the project, resulting in a failure to deliver a product on time. Other people illustrate that the value of equality in specification for the occurrence of software development lifecycle. They show that over half of all defects are due to specification issues because no one takes care of a specification phase. This is the first question. For the second question, we analyze the 12 total paper, analysis and summarize what they tool and method that they use for quality attribute of SRS. Many people focus on complexity and correctness, completeness, consistency. And many people introduce tool technique for that attribute, for this attribute. I show in my paper the strength and limitation for each tool and technique. Because no time. This is some literature review. Should I explain every one, Prof?
Sorry?
I don't know. Okay. Should I explain every one? Or no need?
No
For
need,
this?
just go and explain the general.
Okay. For discussion, we see that all the SRS documents written by using literature language, NL, but literature language still poses different issues like ambiguity and imprecise. The requirement written in a poor way have a negative impact on the overall project. Two are quality attributes. The few paper are working in two attributes, ambiguous or and incomplete requirements. We should we should take more effort in those two quality attribute and also in cost. We didn't find any paper in cost quality attributes. So to overcome these problems, many research attempt to improve the quality of the SRS document. The research are scattered into three main ways to evaluate the quality of the requirements: fully automated and semi-automated and non-automated tools and techniques. This paper, for conclusion and future work, this paper has analyzed several techniques and tools used to measure the SRS quality according to different quality attributes. In the future, we can analyze and measure other quality attributes that have limited research coverage like cost. It would help to cost saving for person the detection and correction of requirements failures. Thank you.
Okay, thank you very much, Shama. Any questions?
Yes, I have some suggestion. Shama.
Yes, Doctor.
Yeah, you have to first thing that it is a review work. You are just starting a review, and it's okay that you have presented a review. But next time also just to show this presentation to your supervisor as well, right? And you must have to tell something that what is new in this review, right?
Yes.
Something new because what you discussed is majority of the things are known. And I'm not the reviewer of this paper and I have not seen that one, but you must have to find out that what are the major outcomes from your review which discriminated with the already existing works.
Okay.
You understand my point?
Yeah, I understand. Yes.
Okay, so reviewer doesn't mean that you have only to collect the papers and you are just presenting the work, but you have to check. But maybe I will check your paper as well. I don't know. Chat or talk with me in my personal email, right? You can still improve it. I think so.
Okay, doctor. Thank you so much.
Okay, thank you. Who is the next presenter?
Professor is Abdulatif, I guess his name. His paper is the first one from SEPA 8. Abdullah Tif.
First one from paper 8.
Yes, his presentation was at 12 o'clock. He talked to me here. Are you here, Abdullah? Tif. Oh, he's presenting. Okay.
He's there?
Yes, I think he's trying to present the screen. We're not listening to you.
Can you hear me now?
Yes, now we can.
Yes, share your screen. Sama, remove your slides. You have uploaded the Sama. Please remove your slides. Yes, good. Thank you. Now I can see you. Yes, Abdul Latif.
All right, sorry. Okay, can you see my slide now?
Yes, we can.
Can I proceed now?
Yes, yes.
Yes.
Good afternoon, everyone. My name is Abdul Latif. I'm here to make a presentation on this paper titled "Smooth-Based Homogeneous Ensemble Methods for Software Defect Prediction."
Which
And
university? You have not added your affiliation. What is your name of university?
okay, currently I'm working with University of Technology Petronas in Malaysia, and I'm also affiliated with University of Ilorin in Nigeria. And some of the authors also work with University of Ilorin, and some are also with Landmark University, also in Nigeria. But I'm primarily now in University of Technology Petronas in Malaysia.
4, 5, 6, 7, 8 authors. How many page paper is there?
I don't get that, sir.
Abdul Latif, this
Yes,
is
sir.
a 12-page authors, 12-page papers in consisting of 8 authors.
Yes, sir.
Okay, so everybody is presenting one page.
No, I'm the only one presenting this.
Okay, what I mean that just to try to avoid this, 8 authors for such small papers is not very justifiable in an international academic scenario. Just I'm giving you some indication that this is not a means everything just reflects something not very good. That in this paper, 8 authors papers in a such a small 12-page papers, 8 authors are there. So each
I quite
paper,
understand, sir.
you understand. So go ahead.
All right, sir. So these are the outlines to guide my presentation. I'll talk on the research background, the research aim, the methodology based on research, and discuss the results, and also give some conclusions that we're able to gather at the end of the study, and also future works for further studies. The main work is based on software defect prediction. It's no gainsaying that we all know that information technology is the bane of all walks of life, and software engineering happens to be at the center of it all. So for all users, for this IT to accommodate so many users, software engineering needs to also expand its scope in terms of process used in developing software. And we can all agree that modern software systems are inherently large, and they have so many interconnected or intercoagulated components or modules. And some of all these software systems tend to be upgraded and updated based on users' requirements. So keeping up with the testing or looking for defects in modern systems now, the traditional way of checking for defects may not be appropriate. So it is good to introduce some other component based on machine learning to help look for defects as fast as possible and as early as possible during the software development phase. So software defect prediction rally rounds using predictive models to identify defect-prone entities, maybe in the source code file, the model, and the component in advance before the software is being released. And it could be in terms of identifying the number of defects or trying to ascertain if a particular module component is defective or not. And the major reason why we need this is just to ensure the quality and reliability of these large softwares that can have it to be, and also to have effective resource allocation during the software development lifecycle. So this can come in during the testing phase, the code review, or the maintenance phase as we can have it to be. So in a nutshell, this is a depiction from this figure one depiction of what software defect prediction really entails. Using software metrics which we use to quantify the characteristics of a particular software, and we use the predictor in this case with the machine learning models or machine learning techniques on these software metrics to determine the defectiveness of any of the components as given in this diagram. But from what we're able to understand from literature is that the performance and effectiveness of these SDP models depends largely on the quality of data used for training the predictive model. Since the software prediction really rally around on the data that's used to train the model, the quality of that data also matters a lot. If the data is good, then we can almost rest assured that the model or the knowledge we are going to derive from such mechanism or from such process would be useful at the end of the day. So we were able to gather that class imbalance is one of these data quality problems that affect the performance and effectiveness of SDP models. And class imbalance only involves, simply means unequal distribution of class labels in the training data set, which usually leads to poor predictive model. And if you have a poor predictive model, that means our software defect prediction model is defective and is not able to identify defects as early as possible. And releasing such software into the market will have very bad effects, not only to the stakeholders but also to the users. So we've identified that data sampling, cost-sensitive learning methods, and assembled methods are being identified as ways of going around this class imbalance. Because class imbalance is a latent problem readily available in not only software defect prediction but in data science. It just happens to occur in software defect prediction also. Any field that happens to deal with data, there is high possibility of such data having class imbalance when you have unequal distribution of class levels. And data sampling, which is a form of, is either you upscale the minority class or the lower class, or you downgrade the majority class or the higher class just to have a fair level ground for both levels. That is what data sampling really entails. And quantitative learning means using a particular machine learning method for the process, but the machine learning method will be penalized for any misclassification that it goes about doing. But having a particular classifier or setting a parameter for quantitative learning is quite worrisome, and it has the parameter may not easily work well with any data you pass into it. An ensemble method means amplifying the predicted performance of a base classifier, either singly in terms of homogeneous or combining combining two or more base classifiers, combining the strength of two or more base classifiers for better output in terms of heterogeneous classifiers, heterogeneous ensemble. So these methods are kind of the primary methods used in going around this class imbalance problem in software defect prediction. So in this process itself, in this work itself, we propose a novel framework based on symmetric minority oversampling technique called smooth and homogeneous ensemble, that is bagging and boosting for software defect prediction. We basically use the smooth or the symmetric minority oversampling technique to balance the data set, to have equal representation of the class labels, and also we use the homogeneous ensemble method to amplify the predicted performance of the base classifiers. So combining these two together to form a framework is what we're proposing to resolve not only class imbalance, but to give a better software defect prediction models. So in order to gather research, we have this framework for the experimental process. We have the software defects coming in at the front. Then we have the smooth sampling method. Our choice of using smooth sampling method for the data sampling method is because it's based on its usage and it's based on the popularity as used in other existing studies in SDP. And we use K-fold cross validation to evaluate this. The reason why we're using full cross validation for the model against the other split and test is just to go against this this latent class imbalance, so that every instance in the data set will be used for training, and also every instance data set will also be used for testing, as this data set will be divided into chunks, and these chunks will be iteratively used for training and testing accordingly. And at the end, the data will be divided into test data and training data, which will be worked upon. And also, we pass the training data into, we test it based on the base classifier, that is using the variation network and the decision tree, and using the homogeneous ensemble method, that is the bagging and the boosting method. And at the end of the process, the Bayesian performance will be evaluated and compared to look to see the effectiveness of all these methods. So the table 1 shows the classification algorithm considered. We use the decision tree and the variation network, and this shows the parameter setting as used in this particular study. And the homogeneous ensemble also, this table 2 shows the homogeneous ensemble used alongside the parameter setting. Then the software defined data set that was worked upon, we selected these 5 data sets from the NASA repository, which is an open source software repository that is always used for software defect prediction. The first column shows the data set, second column shows the number of features, which ranges from 22 to 40, and we have the number of modules accordingly. Then we have the imbalance ratio, which is the ratio of the defective instance to the non-defective instance. So the higher the ratio, the higher the imbalance in that particular data set, and we have it ranging from 2 to 7. So the performance metrics used for measuring the ensuing models from the experimental framework is based on accuracy, F measure, and area under curve. And to state categorically, since we know that this class imbalance affect the predicted performance of SDP models, using only accuracy to measure the performance will not do well enough. So that's why we included F measure and AUC that works independently of the accuracy. So they tend to give results that can speak for itself other than the accuracy. So from the first instance in table 4, we have the prediction performance of variation network and decision tree classifier on the original data set. We can see that the average accuracy for each of the base classifier is 71.35% and 77.14% respectively on the original data set, and the AUC is 0.69, 0.65, which is we can say it is moderately okay, because the range for AUC value, for good AUC value, is from 5 to 1. It's from 0.5 to 1. But you can have it to be 0.69, 0.65. It is fairly above average, which means we can easily attribute the occurrence of this value to the underlying class imbalance or other data quality problems that tend to exist in software defect prediction. And we can see the F measure also, which happens to be averagely 0.73 for variation network and 0.76 for the decision tree. But when we now used the variation network and decision tree on the balanced data set, that is on the data set that we've already used the smooth data sampling method to balance based on 50-50 ratio, we have the accuracy, the average accuracy of variation network to increase from 71.35 to 78.63, and we have that of decision tree also to increase significantly to 81.08. That is to show that balancing the data, it gives a good effect, or it increases the performance of this base classifier. We can see that in the accuracy. We can also see that in the AUC value, as we have the AUC value to moving towards the upper part, moving towards the upper bound of 1, which increases from 0.69 in the case of variation network to 0.82, and for the decision tree, it gives us 0.83 on the balanced data set. And same thing can be seen in the case of F measure. That is when you use the base classifier on the balanced data set. So comparing these two tables, you can see that in this case, using the data sampling as a way of using data sampling on the data set and then applying the classification algorithm tends to improve the performance of the SDP model. And this our result agrees with other existing studies that proposes and postulates the usage of data sampling method in software defect prediction. Further, we also try to look at the effect of assemble method on the original data set. So table 6 and table 7 shows the performance of bagging assemble and boosting assemble on the original data set. We can see from here that the average accuracy for the bagged Bayesian network is 71.5, and the average accuracy of the bagged decision tree is 80.66, which are quite higher than the individual performance of BN and DT. And you can also see in the case of the boosting ensemble also, the accuracy of Bayesian network also increases, and the accuracy of decision tree also increases. And this also shows in other metrics in terms of the AUC and the F measure for both kind of homogeneous ensemble, that is for the bagging and the boosting accordingly. And averagely, their respective AUC value is more than 0.6, 0.7, which we can still take to be okay. And we can put this we can translate this result to say that ensemble method really works well with imbalanced data, but the performance of the base classifier can still be improved, which really gave us the idea of combining both assemble and data sampling together. So table 8 and table 9 shows the performance of assemble and data sampling together on each of the base classifier. So as we can see, bag BN plus smooth give us an average accuracy of 80.09%, and bag DT plus smooth give us an average accuracy of 85.12. And also, boosted BN plus smooth give us an average accuracy of 81.94, and boosted DT plus smooth also give us an average accuracy of 86.8 as an average to be. And the respective AUC value, in the case of bag DT, we can see that it's very close to the upper bound of 0.91 averagely as AUC value. And also in the boosted DT, in the model for boosted DT with smooth, it gives an average AUC value of 0.93 for DT. And we can see that both base classifiers in this case have their respective performance improved when we combine both the data sampling and the assemble methods together. So table 10 now shows a clearer picture for us to see and compare on a large scale. We can see from here the performance of Bayesian network and DT averagely, and looking at when we performed only the sampling method, we can see that the performance of both Bayesian network and DT increased, as you can see here. And when we use the assemble method on the base classifier only, we can also see the increment, though it is not as significant as the data sampling method, but from these two, we're able to gather the finding that both data sampling and assemble method can truly improve the performance of this classifier, and this agrees with other existing method, as we said earlier. But this is our proposed method where we combine both the homogeneous assemble, that is bagging and boosting, with the data sampling method, and we can see that their result actually outperforms the base classifier and when we use the base classifier and the data sampling, and when we use the base classifier and the assemble method. So just to give a conclusion to this, we can see that this study basically involved the combination of data sampling, that is smooth and homogeneous assemble, and the effects of data sampling and homogeneous assemble are empirically validated from this study. And the experimental results show that the smooth technique can improve the precision performance of not only the base classifier, but the homogeneous assemble method inclusive. So the proposed approaches that we already given here significantly outperform the base classifier, and therefore we therefore recommend combining both data sampling and assemble method in SDP as we have it to be. So in future work, we consider using other assemble method, that is the heterogeneous assemble method, and other data sampling methods also, to see how well we can work around this, and to carry out an extensive empirical study, to have a full-scale empirical study to show the impact of data sampling and assemble method in SDP, to further guide software practitioners and other researchers on the usage of data sampling and assemble method, not only in the SDP and other allied fields that tend to work with, that tend to have class imbalance as a data quality problem in it. Thank you.
Thank you very much. So by the time, let's start to the next presentation. I think it is.
Hello.
Hello.
Hello. I think I am next.
Menzi.
Yes.
Yes, Menzi.
They didn't pay some people.
Signing for some days.
Who?
Yes, some of my colleagues. I'm not signing for some days. I didn't pay them.
Maybe you can present.
Is anybody ready?
Can you see my screen?
Yes.
You can see it. Okay, great. Let me hide this. Oh, okay. Okay. So my name is Menzies Kosana, and I'm from the University of KZN. I'm a master's student, and I would like to thank you all for giving me this opportunity to present my work. And my topic will be an intelligent machine learning-based real-time public transport management system. I'd like to thank my supervisor, Absalom Ezoko, and Nadim Rana, and Shafi Abdul Hamid for assisting me in some parts of this work and giving me advice. Okay. Have you experienced this? If you don't know this pain, consider yourself lucky because according to Statistics South Africa, 76.7% of South Africans rely on public transports for their daily commutes. And that is 43,504,240 people who are using public transports in South Africa every day. And yet little to no technological innovations are being made in this sector. The main problem that affects this sector is that the commuters are not informed or well informed about the current status of the buses. Like, for example, how far the bus is from the bus stop and how long will it take for it to get to the bus stop, and which other buses are available for the commuters to take. And also, this is just not a problem that is the unavailability of information is not just a problem that affects the commuters, it also affects the bus operators, as they want to be able to sort of like assign their buses properly to drivers and keep track of them remotely, and also know how many passengers they can expect per given route. And this is where our solution comes in. So our proposed solution is, we named it RN Bus, a real-time public transport management system. So with our solution, we will provide real-time location of the bus anywhere it is to both the commuters and bus managers. And also it will allow the bus operators to manage their buses remotely and also predicts the number of passengers they can expect per given route. So this is the architecture of our system. So our system is mainly composed of two subsystems, namely the mobile application and the web application. The mobile application is used by the commuters and the drivers. So let's say, for example, if you are a commuter and then you have our mobile application, you can use it to check where the bus is and view the schedule and other related information about the bus. And if you are a driver, you have to turn on the location and then log in our application so that the bus manager and the commuters can be able to see where your bus is currently located so that they can know how long they can wait at the bus stop or to which routes is your bus going. And the web application is used by bus managers or bus operators to manage their fleets of buses, to assign drivers, and also to sort of like make predictions as to how many commuters or how many passengers they can expect per given route. To achieve this complex system, we made use of cloud computing services, and we went with Firebase specifically. That was just so the ease of use for Firebase and how easily it integrates with mobile systems. So within Firebase, we used these services. Firstly, the the real-time database, which allows us to sort of like store data across all platforms and have it updated synchronously in real time. And also the authentication service, which helps with security and storage for storing documents and user profile pictures, and hosting for hosting our web application on a live server, and test lab to run tests on our mobile application and figure out problems on it. These are the languages and APIs that we use for our system. So I won't go through all of them. Okay, so now I'm going to show the prototype of our system. So I'm going to start off with the mobile application, which is used by the commuters and the drivers. So these screens, this part is for when you are logged in as a commuter. So the first screen shows the nearby buses. So the idea behind this is it only shows buses that are within a 5 kilometer radius of where you are. But then you can change this to your preference. If you prefer to maybe broaden up the radius, you can do so if you like to. And the second screen is it shows the map, which sort of like shows the broader view of all the buses, and you can sort of like pan around and look at the buses, and you can, when you click on the bus icon, it tells you where the bus is going. For example, what we have here. So that one is going to Chesterville. And the second screen, and the third screen shows a list of bus schedules. And you might be asking yourself, why do we need this application if we also have bus schedules? But then the reality is, even though bus schedules have time that are set on them, there are some situations that in real life the buses don't stick to that time because of like traffic congestions or natural disasters or anything that is unpredictable. So this application will be used in a way that it keeps the commuters up to date no matter what happens. And the screen is when you are logged in as the driver. So when you are logged in as the driver, you're presented with this screen of which you can click start on. As soon as you click start, it starts tracking your location and sends it to the commuters and the bus managers to sort of like see your bus as it moves around. And also there's an option to change the bus code, like the bus. Let's say maybe if you are a driver, you're driving for one bus in the morning, and when you're changing to a different bus, maybe later on in the evening, you put in the bus code, which is a 16-character alphanumeric code that you put in to sort of like switch from one bus to another. The reason why this code is so long is because it's for security purposes, and drivers obtain this code from the bus operator. So the drivers cannot just switch buses by themselves. They have to get this code from the bus operator so that they can switch the bus that they're currently driving. So now I'm going to present the web application which is used by the bus managers. So this is how the web application looks. So it has like 3 tabs. The first tab is the map tab, which shows like the full screen view of all the buses that are currently in transit to the bus operator. So the bus operator can click in one of these icons, for example here. So if they click on this one, it shows that the bus is going to Chesterville, and the number plate of that bus and the driver who is driving that bus. And remember that in the commuter application, we had something similar, but then it was not as detailed because it is it is unnecessary for commuters to see who, like the actual name of the driver and stuff like that, because might be sensitive information. But then it is shown to the bus operator because they are managing that driver, so they have to know who is currently driving that bus. And also this can be useful for situations when the bus is maybe stuck remotely and it needs some help, so that the bus operator or the bus manager can be able to pinpoint the location of that bus. So our result, the prototype, the mobile application was very user friendly, and it was very compact, and we used our APIs so well that we sort of like we minimized the size of the file so that it makes it easy for users to download it without having to without having it requiring a large amount of space for it to be installed. And it is reported that the average file of an Android application in the Play Store is around 11 megabytes, but our application is around 5 megabytes. So that is almost half of the average file size, and this will make it easier for users to install it. We then ran test, excuse me. We then ran test on the test lab from Firebase to check the performance of our mobile application. So when we had our mobile application running for 2 minutes and 10 seconds, this is what we observed, and we observed that it doesn't consume a lot of mobile data, so it sends very little network request, which is very good for the user experience, so that they don't have to have a lot of data to connect to the application, and also it doesn't use up a lot of memory, and it doesn't use up a lot of CPU too. So it's a very well stable application. That can be run in almost any Android app, in almost any Android device. And also, as I mentioned before, that our system would allow the bus managers to be able to predict the number of passengers that can be expected per given route. So this is how our machine learning model was integrated. So with the mobile application collects the data, the road data. For example, when the bus driver stops at a given bus stop, at that time they click a button and then say how many passengers they were onboarding at that particular bus stop, and then that data is collected daily and then stored in the central database, on which that data is taken to train our model. So when our model has been trained, the bus operator then can query on that model to make predictions on the number of passengers they can expect for that given route based on historical records. So for our training data sets,
excuse me, you have one or 2 minutes left.
Okay, I'll try to be quick. For our training data sets, we use a training data set that has around 98,000 entries, and it had the following features. It had 5 features: the number of boardings, and the data, the day of the month, and the day of the week, and the routes. So this is how it looks like. This is a sample of it. And our model is, we use the multi-layered perceptual neural network, and it had the value activation function. And
please come on conclusion. Please come on conclusion.
Sorry?
Please come on, conclude your work now. We have to start the new session.
Okay. So, and this is we trained our model on 3 different types of data, and then the best performing data was resulted from the data that was standardized, as shown on the far right. So the current limitations of our system is battery drainage. We found out that our mobile application drains a lot of battery when it has been running on the mobile application for long. And then for future work, we are planning to use different models to predict the number of passengers that can be expected and deploy our prototype into the real world. So in conclusion, developing these types of mobile system will make public transport far more accessible to the people, and with more people using public transport, there will be less traffic congestions and lower carbon emissions, which will in turn help mitigate the effects of global warming. Thank you. Any questions?
Thank you. Thank you so much for your presentation. It took so long
Hello.
than usual. Yes.
Hello.
Yes.
I think I'm the next.
Okay, George Boule.
Estefania Llanes.
With the paper of the George Boule, Franklin Salazar,
Yes.
Maria Morosco,
Yes.
telemetry and radio surveillance, right? Please
Yes.
present, please present,
Okay.
and make it short, right?
Okay.
Okay, we have a presentation to start. Go ahead, be fast.
Okay. Hello, everybody. Can you see my screen?
Yes, yes, we can see, but we share your slides, not the screen. Go for the other applications.
Okay. Hello to everybody. My name is Estefania Llanes. I'm from Ecuador, and I'm going to talk about this research project called Telemetry and Video Surveillance System in a UAV for the control and monitoring of long distance. This project is based on the unmanned aircraft systems that includes unmanned aerial vehicles, ground stations, launch mechanisms, and also the communication links between the aircraft and the ground stations. This research project was carried out in order to provide the Ecuadorian Air Force with an UAS for long-distance monitoring and surveillance missions. Okay, to fulfill this purpose, this system was implemented in a prototype provided by the Ecuadorian Air Force, which has the following mechanical characteristics, especially designed for this, like we see on the screen. For the location of each component, certain restrictions must be considered, including the proper distribution of the payload to achieve the correct stability and control of the aircraft. It's important to note too that the physical structure with which the aircraft is built is made of carbon fiber and taking into account that is a conductive material which could affect the communication systems. The UAS is divided into three major segments. First, we have the air segment, which refers to the aircraft fully equipped with sensors, the micropilot, and the actuators. Second, we have the communication segment, which consists of the telemetry and video links, both long distance, and each one was configured with different frequency to avoid overlapping them. It's important to note that telemetry and link video are totally independent, thus giving priority to telemetry data and over video. And finally, we have the ground segment that consists of the control and control and monitoring software for flight variables, the visualization of the images captured in the air, and as well as the command controls for takeoff and landing the aircraft. For the control and monitoring of flight variables, as well as the configuration and calibration of like IMU sensors like accelerometer, magnetometer, gyroscope, and also the GPS sensor, the software mission planner based on the different positions that the aircraft can have. Also, we used to current control software for the visualization of images captured by the aircraft. The control for the manual command of the aircraft was also configured. The joystick levers were configured for the movement of the control interface, as we can be seen in the image. Also, the configuration of a special lever that allows the selection of flight modes that aircraft can have. Here we can see the different flight modes. We use three important kind of flight modes. First, the manual mode, in which the pilot has full control of the aircraft. Then auto mode, in which the aircraft follows the program mission from the ground station. And RTL mode, or return to launch mode, where the aircraft returns to the point where it starts to fly, or the home point. Also, we use an auto-tune mode too, that was used to take the control values in the pitch and roll movements, and a loiter mode that the aircraft fly in circles around a certain point. And here we have the test and experimental results. For the validation of the implemented UAS, we did a total of 6 tests for calibrate errors. We did an operational test that was an overflight in a town of South America Amazon region, in which the maximum distance from ground this station was 5 kilometers, and the total perimeter traveled by the aircraft was 9 kilometers. So in this image, we can see the program path in the ground station, and here we can see the path done by the aircraft. It results that the control system is correct and functional. Another way to certify the correct operation of the system control is analysis of heights. As we see in the table, in each one of the waypoints, the obtained height is approximate to the desert height. That shows in a minimum error between them. Also, in the same way, here is the graph taken for the logs saved in the graph in the micropilot, where is determined that in most of the mission, speed is stable in auto mode. It's important to note too that the battery consumption overcome the 80% of the total capacity of the total test time in 20 minutes. For the analysis of telemetry signal levels, in the operational test number 7, carried out in Amazon zone in South America, the signal levels are most efficient, which confirms that for environments with high vegetation and humidity, the telemetry transmission system works effectively, and the navigation distance of the aircraft can be increased. On the other hand, the previous data showed that efficacy can be affected in environments with less humidity or in presence of bad placing of the antennas. For the analysis of video signals, we have to test. Only test 6 and 7 are compared, but both tests have stable video transmission, but when reaching a distance of 2.5 kilometers in test 6, there is a link lost. The video recording of each test can be seen in the image presented. The only test that was successful at the distance greater than 3 kilometers was the operational test that reached a distance of 3.5 kilometers until the communication fell down. With each of the results obtained, it has been determined that the transmission quality of the images is superior in test 6 and 7.
Conclude, please. Please conclude your work. We are being late. Please conclude your work. Come on, conclusion.
The conclusion for this project, we can see on the screen. The UAV used for this project is medium range, having a structure suitable for developing video surveillance missions and the borderline in areas with difficult access. This low-end UAV was converted into an operational aircraft as it performs long-range missions with constant monitoring of telemetry data and high-definition video. Also, through this test carried out in the operational area, communication range of 5 kilometers for telemetry and 4 kilometers for video only, it shows a loss of 10%. And that is all for my presentation. Thank you.
Thank you so much. Please, if you have any questions, we invite only 1 or 2 questions. We are being late for starting to the next session. Any question, please? Please ask. By the way, you have not presented any of your screen. Your PPT is on the screen. You only presented, you just share the screen, but not the presentation. So it's all. Thank you so much for your presentation and being us. We have to start our new session. This is the international workshop. It is symposium on software quality. This is the first one. ISSQ is going to be start now, and I guess that we have presenters already in the room.
Yes.
Yes. So I think yes. Who is presenting the first paper? Elias?
Yes. I'll start?
Yes.
Hello.
Let us start. Yeah, let us first find out that who else is present. The second presenter is present. Manal is also there, I can see, right? Software
Hello.
requirement category. Hello.
Yes, sir.
Manal is also there. Anisha Kumari, Ranjan Kumar Behra is also there.
Yes.
Okay, well. And then the Ilchin is also there, right?
Yes, I'm here.
Okay, Ilchin. Let us start with the first presentation. Please mind the time because we are running late, already 30 minutes late now. So please try to finish your presentation in 8 minutes, 2 minutes for the question and answers, and let us see. We will discuss overall at the end of the session, right?
Okay.
I saw the Robertus is there, right? Anywhere. Yes, start, please.
Okay.
Elias.
Can you see my presentation?
Yes.
Okay. Hello, I'm Elias Kalpsoglu from Greece. I am from the Center for Research and Technology, Hellas, and I'll present you the paper entitled Cross-Project Vulnerability Prediction based on software metrics and deep learning. Vulnerability prediction constitutes a mechanism that enables the identification of software vulnerabilities early enough in the development cycle, improving the security of the software products. Vulnerability prediction models are normally built based on machine learning techniques using software attributes as inputs to separate vulnerable files from the neutral files. Several vulnerability prediction models use text mining or static analysis alerts, and these techniques present promising results on within-project prediction, but not sufficient results on cross-project prediction. In bibliography, there are studies that utilizes text mining and demonstrate very good results, but only for within project prediction, as I said. These models have failed in cross-project, in contrast with the models based on software metrics, which look quite promising. Some of them utilize deep learning techniques, but in order to construct new features and not for the prediction. So our idea is to develop deep learning models for the construction of the vulnerability prediction models, focusing on the cross-project prediction. An important part of our analysis is also the fact that we construct our experiments based on real-world vulnerability data retrieved from actual vulnerability databases and vector advisories. This dataset is the vulnerability dataset provided by Walden et al., and it contains 3 popular web applications: the Drupal, the PHP MyAdmin, and the Moodle. In total, there are 112,947 versions of PHP files, but some of them are duplicate, which means that assemblies with all the metrics with the same value. So we remove the duplicates and we retain 21,445 samples. At each one of these samples correspond 12 software metrics. Before starting the training of the models, we had to do the pre-processing. The most difficult thing with this kind of data sets is that they are highly imbalanced, which means that the neutral files are much more than the variable ones. So we applied an undersampling technique to reduce the samples of the majority class, that is the neutral class. It is crucial to apply the undersampling only on the training set in order to retain the right testing conditions. After that, we also normalize our data using the min-max normalization technique. Furthermore, we study the statistical significance of each file level software metric over the existence of vulnerabilities. So we applied the tree-based elimination technique, which uses the feature selection mechanism of random forest and measures the importance of each feature, indicating to its discriminating power for the prediction. In this slide, I show you the results of the feature selection. We can see that the projects MyAdmin and Moodle exhibit high similarity according to their most important metrics, whereas Drupal is quite different. The 2 dominant projects, Drupal, Moodle and MyAdmin, the 3 first metrics are exactly the same, and specifically, these are the hostage volume, the number of outgoing external unique calls, and the cyclomatic complexity. In this slide, I will present you the machine learning models that we trained. First of all, we trained a random forest model, like Walden et al. Did, and then we also trained support vector machines, XGBoost model and several model, and the multi-layer neural network, the famous perceptron. And then we compare them. There I present the final values of the hyperparameters that we chose for the neural network by performing an extended tuning process. For the models comparison and also for the evaluation of our models, we use these 2 metrics, the recall and the inspection ratio, like Walden's did. These metrics, the inspection ratio metric is an indicator of the effort required to identify a vulnerable file. There, within project prediction, we train models using the data of one application, and we test our models on data from the same project. For example, training on Moodle and testing also on Moodle. For the testing, we apply 3-fold cross-validation in order to avoid a potential bias in the results. We found out that the best model is the random forest model, and that is our notice for every project, every one of the 3 projects. And that is in line with the work of Walden. And also these results are quite sufficient in general. However, in cross-project prediction, where we train models on 2 projects and then we test them on the other one, we find out that the random forest algorithm is not able to predict the variable files efficiently. On the contrary, the multi-layer perceptron is quite better, performs much better, and has good results. It proves that we can use deep learning models to predict variable files in different projects rather than the project used for training. Of course, we can see that these good results depict the first 2 cases of that table and not the third one, because the last one predicts the vulnerabilities on Drupal, which is the project with the smallest similarity between the 3 of them. So we conclude by saying that deep learning models constitute a promising solution for cross-project vulnerability prediction. And also another interesting conclusion is that the performance of the models in cross-project prediction is enhanced when the project exhibits similar characteristics with respect to their software metrics. For future work, we address the need to extend our analysis to projects written in other programming languages rather than PHP, and also to collect more vulnerability information from additional PHP applications. We could also replicate our study by using metrics calculated at lower levels, such as class or function level. Thank you for your attention. I'm open to answer your questions.
Yeah, thank you so much. It was an interesting lecture, and I hope that all the other authors also enjoyed this one. We are in the session of International Symposium on Software Quality. So this was the first presentations. Please, questions.
Hello, are you hearing me?
Yeah.
Okay, I am Professor Ali Idri from University Mohammed V in Morocco. First, thank you very much for your presentation. If you can come back, please, to slide number 7.
Yes. The preprocessing.
The slide when you present different machine learning techniques with their performance.
Okay. This one.
Slide number 7, please.
Can you see my screen?
Elias, we cannot see your screen. We can see someone else's screen, actually.
Yes, why is happening?
Please, Arom Junior Garable, please remove your slides from the screen. Arom Junior Gabriel, please remove. Yes, thank you.
Okay, so I'll stop and I'll start again.
Yeah, don't worry. Just I have 2 comments. You mentioned in this slide, if you don't find it, you mentioned next slide. Yeah.
Oh, yes.
This one. So here you mentioned several machine learning techniques, random forest, super vector machine, and you mentioned the first deep learning. I see this is not deep learning technique. This is only machine learning classical techniques. I didn't find any deep learning techniques.
The multi-layer perceptron has many layers, 4 layers, so we mean deep.
But it's not a deep learning technique. A deep learning technique means you have, for example, convolutional neural network. You will have VG16 and other architecture, more complicated than.
Yes, it's simpler, but it is a deep network.
Okay. My second question, you mentioned ensemble method, but which ensemble? What are the single techniques? Homogeneous ensembles, heterogeneous ensembles? you didn't mention any information about which kind of ensemble you used in this study.
What kind of?
Ensemble.
Ensemble. All the other ones. And I had the perceptron as the final model.
But ensemble means that you have single methods there. What are the single methods?
Ensemble is a contribution of some models, and then there is a final model for the output. That is what I mean.
Okay, okay. Thank you very much.
Thank you.
Yes, any other question? Okay, sorry, due to the lack of time, we are going for the next presentation. And I think the next presentation is the Manal. She is going to discuss about the software requirement catalog on accessibility, right? Manal, are you ready?
Yes, I'm ready, sir. Can you hear me clearly?
Okay, please share your screen and you are welcome.
Okay.
Share your screen and then share. Yeah, it is on.
Can you see my screen, sir?
Yes.
Full mode? Thank you. Well, hello, my name is Manal Kharbouch. I am a PhD student at University Mohammed V, and I will be presenting the paper entitled Software Requirements Catalog on Acceptability, Usability, Internalization, and Sustainability for Contraception in PHR. This presentation is structured as follows. I will start with a brief introduction into the paper, then I will describe the study's method. Next, the result of this paper will be more explained and discussed. Finally, I will outline our conclusions and future work. Well, researchers highlighted that the development of emerging contraceptive solutions that improve the understanding of use and the existence contraceptive, expanding expectance and access to contraception will help alleviate the growth of unmet demand for satisfactory contraceptives worldwide. However, the need for more theory-guided research to support the development of future mobile health applications to determine their clinical efficacy is highly stressed, especially in the field of contraception. These apps are widespread. However, in-depth research addressing the effectiveness and acceptability of these apps is lacking. Of course, usability assessments is an essential feature of user-centered design. However, more research is needed to understand the gaps between intent, actual, and ongoing use of the application. Moreover, limited reliance on personal health records by individuals is a real problem for several reasons, such as the use of medical terms that are generally difficult to understand by users, the lack of language support, as well as social and cultural barriers. Yet, having solid awareness about contraception solutions does not necessarily induce them to be used, since the bottleneck of modern contraception users is still misconceptions entrained by social and cultural influences, which stress the importance of internalization in contraception applications. To the best of our knowledge, no software requirements catalog for contraception and PHR has yet been developed. Therefore, this paper aims to develop and elaborate a requirements catalog suited for the contraception apps with respect to the IEEE 29148, the version of 2011 ISO-IEC IEEE standard. This catalog mainly focused on acceptability, usability, internalization, and sustainability for contraception and PHRs. Now, moving to the method we used. In the interest of including the distinguished SRS for the catalog, the present study relied upon the following: previous studies concerning software quality, research dealing with usability, acceptability, and the fair difference between the two aspects, and software requirements catalog that implemented sustainability and internalization, and reusable catalog concerning software usability specification. Likewise, the following set of standards and models were applied in the extraction process of the requirements. First, the ISO-IEC 25010, which is considered the cornerstone of a product quality evaluation system. The ISO 9241, the version of 2011, which is a multi-part standard dealing with the product's uses characteristics. It offers a framework for understanding the concept of usability in its application to situation in which people use interactive systems, among other systems. Third, the ISO TR 14292, which is used for the definition of the scope and context of personal health record, and the W3C standard for web and mobile devices, along with the unified theory of acceptance and use of technology that explains the user intention to use an information system and sequence user behavior, which is a psychology model. Moving now to the catalog development, the generation process of the catalog consists of 3 steps. The first one, which is resources identification, which are the aforementioned related studies and standards, and the requirements extraction, which are stands for from the highlighted resources that we already identified. And third and finally, the catalog generation from the extracted requirements conforming to the IEEE standard that we already mentioned, which contains a set of provisions for the process and products related to the engineering of requirements for systems and software products and services throughout the life cycle. And in order to assess an MPHR for contraception using the catalog of requirements of the developed software, and to validate the latter, we elaborated a questionnaire that consists of 30 items based on the catalog guidelines. This questionnaire has been used in the evaluation of the app Clue Period and Ovulation Tracker, and was exclusively tailored to this app. Relevant specification. The answer to the questions adopted in this study has 3 choices, which are as follow: yes, if the application offers this feature; no, if the application does not support this feature; and partially if the app does not fully respond to the statement detailed. And we gave a pointing system. Moving now to the results and the discussion of these results. In order to extract requirements related to contraception apps prior the catalog generation, a literature review was conducted within the software engineering, psychology, and health fields. Contraception MPHR requirements have been extracted based on the distinguished standards and models previously identified and on existing contraception apps for iOS and Android platform in scientific literature on contraception. Note that the requirements for the internalization, sustainability, and acceptability have been slightly adapted to the contraception MPHR according to literature. You will find the contraception MPHR requirement detailed in Table 1 of the paper. The general structure now of the catalog is thus adapted to recommended SRS structure from the aforementioned standard as shown in the figure. And now for the application examples to validate the catalog, the assessment questionnaire response for the application Clue Period Tracker evaluation are as follow: 22 yes, 1 partially, and 7 no's, which thereby the score of this app is 75%. This score is considered as a very high score since 73.33% of the answers were positive, yet there is still room for improvement. Although Clue Period Tracker and Ovulation app recorded a perfect score in terms of usability and acceptability, however, the app scored 50% in internalization and 63.64% in sustainability. So thereby, to improve this app, it is recommended to cover sustainability in all its dimensions in future version of this app, and to bridge the cultural and language barriers among women seeking contraception from different backgrounds to enhance the international aspects of this app. Moving to concluding our study, this study has presented the software requirements catalog on acceptability, usability, internalization, and sustainability for contraception MPHR, which is the SRS repository for contraception stakeholders to help them design, identify, and verify requirements for acceptable, usable, internalized, and sustainable contraception MPHRs. The requirements presented in this study were determined mainly from the results of literature reviews conducted in this domain and from analysis of standards related to software engineering, psychology, and e-health. For future work, we intend to 1. Evaluate the moderation effect of personal innovativeness on each subcomponent of acceptability requirements and its influence on the intention of use of mobile application for contraception. Second, make a progress in improving the catalog of requirements by harmonizing the multiple requirements distributed across different sources and detailing those requirements given like much detailed and still having a simple topics, but will be able to guide stakeholders into perfecting contraception in BHR. And third, to develop a validation method to determine if the contraception in PHR meet the requirements mentioned in this method, which evaluation will be carried out in a family planning center in Rabat, Morocco. This will bring my presentation to an end. I would like to say that this.
Thank you so much.
Sorry.
Thank you so much for your wonderful presentation.
Thank
you.
In
fact, your confidence is well appreciated for your presentation in front of your supervisor. Professor Ali is also there. I'm happy to see you. Please have any question? Questions, please. There's a lot of software engineers are in the midst of the audience, and I invite you all to encourage by asking the questions to the presenter. Hello, in absence of I want to ask you that actually once you are developing a catalog means what is how can you discriminate that what are you doing and it is really unique with the already existing works and the other catalogs? Yes.
Well, take an example of this catalog that we conducted. We conducted a literature review and we have a medical doctor and the gynecology center of in a gynecology center in Rabat in Morocco. So we have both the software overview and a medical overview of what there is in the literature right now. And we noticed that there is no catalog for contraception apps, and that highlights all these requirements, which we found in a previous study that is not published yet, that are the most important for contraception applications.
Good,
Does that answer your question, sir?
It's okay. I understand. That was my questions. Thank you so much.
Thank you, sir.
Thank you for your presentation once again. I invite the next presenter. This is Ranjan is there or Anisha Kumari is there?
Yes. Ranjan Kumar Behra is there. Ranjan Kumar Behra.
Ranjan, please present. You mentioned
Yes.
that Anisha also want to present, right?
Yes. But
Anisha is also there?
No.
Okay. Please. Okay, present. Start.
I'm sharing the screen.
Yeah, please share the screen. It is not shared yet. And keep only 8 minutes for the presentation, right? Go directly to your work. Only 8 minutes, 2 minutes for the question answer. Go ahead.
Okay, sir. Just I'm not unable to share my screen. Just
go to the left hand side on the share your screen. Corner left hand side.
On the bottom left corner of the screen. Yes.
Is it visible, sir?
Yes. Go to the title and move to next.
Yeah, this is Ranjan Kumar Behra, and I'm doing PhD in NIT Raulkela, India. And my research area mainly focus on the social network analysis. And this is this title of the paper: Quantifying Influential Community in Granular Social Networks using Fuzzy Theory. Basically, social networks are generally represented in the form of graph structure, where node changes represent the social entity and edges corresponding to it. That relation between them. What is community? Community is nothing but a dense subgraph in which the nodes are densely connected as compared to nodes outside the subgraph. Basically, my objective is to identify the community which is more influential as compared to other communities. And what we mean by actually influential community? A community is said to be more influential if the members of the community is highly influential as compared to members of other communities. So These are the few research area of social network analysis, community detection, link prediction, central area analysis, influential analysis. It's all four are the part of this influential community detection. And the community is a group of nodes in the network where the links inside the groups are more dense as compared to links between the group. And that means inside the group links should be more connected as compared to the nodes between the group. This is a few application area of community detection, recommendation system, fraud detection, social science bibliometrics, load balancing for parallel computing, scientific collaboration analysis, web page clustering, gene analysis. These are the few applications of our research program. What are the basic research challenges? Actually, challenges is to identify the community because the exact boundary of a community we don't know the social network because a node can be member of more than one communities. Overlapping communities are there, so it is very difficult to identify which member, which communities, which member is belongs to which communities. The second challenging task is to measure the tendency of an user in a community. That is the major challenges. Because that can lead to modeling the network evolution also. And the most important challenges is that process this large scale network because it consists of millions to billions of nodes and edges, and the nodes and edges are adding continuously over the time. So by doing traditional tools, it is very difficult to analyze this one. So we have used here the map reduce approach, distributed approach. In a cluster approach, we have used our algorithm is basically the proposed model is in two phase, basically in two phase. One is community detects first. In the first phase, we are detecting the communities, and then second phase we are maximizing the influence of each communities. And for the community detection process, we have used fuzzy theory. And one more thing, more important thing, basically the social network consists of a single nodes and the edges between them. But what we did, we have modeled the actually social network to fuzzy granular social network, which is different kind of social network where the basic unit is not a node. Basic unit is a macro unit of nodes. Means it may consist of more than one node. So they are known as granules. They are known as granules. So we can say fuzzy granular social network is a set of granules. In the first phase, communities are detected in fuzzy granular social network. The imprecision of a member for a communities are measured. And fuzzy and rough set theory are used to explore the user communities. And our algorithm is mainly suitable for detecting overlapping communities. And then the second phase, we are calculating the importance of each node using eigenvector centrality. After calculating the importance of each node in a community, we are measure the influence of the communities. And let me go to directly fuzzy granular social network. What is fuzzy granular social network? A social network can be modeled as fuzzy granular social network, where network consists of set of macro units known as granules. Like general social network consists of set of nodes, individual node, but fuzzy granular social network consists of set of macro unit known as granule. And each granules may consist of more than one node. The basic unit of social network is granule rather than individual node. A granule around a node, how the granule will be constructed? Granule will be constructed around a particular node. That node is known as granule representative. This is our model actually. The fuzzy granular social network model. They may consist of four parameters: C, V, G, and AC. What is C? C is a set of granule representative around which granules are created, and V is the set of vertices in the network, and G is the set of all the granules around each granule representative, and AC is the granule having center C. These are some of the few definitions which will be very useful to understand this fuzzy granular social network. What is granule radius? Granule radius is the maximum allowable port distance of a nodes in a granule center. Granule representative, the node around which granule is being formed is designated as a granule representative. Granular degree, like normal degree, a degree of a node means the number of nodes, number of neighboring node it is connected, that is known as degree of a node. But here we are, as the basic unit is granule, so we have to calculate the degree of each granule. What is the degree of, and each granule is represented by a fuzzy set, and the cardinality of that set is known as granular degree of that granule. And theta core, a granule theta is something that is we have made a threshold, the theta. The granule AC can be represented as a theta core if the degree of that granule is greater than or equal to theta. And this theta, and very important point is to fix the theta, the value of theta. This is our problem statement. Problem statement is the social network may be consists of three parameters C, V, G. This is the main thing. The objective is to identify a community C such that it is non-empty subset of granule that satisfy the following constant. For all pair of granules AP and AQ, AP and AQ are the two granules that belongs to granule set, and AP and AQ must be connected core. And a connected core means must be connected theta core. You can say means they must have degree more than theta. And one more thing, suppose a granule is there, AP is there, and we have to include all other granule in that community. So this is a function which is known as normalized granular embedded function, which is used to measure the embedding score, granular embedding score between two granules. If this embedding score is greater than epsilon, then we can include that granule in that community. So two parameters here we can see. One is theta and epsilon. We have to measure, we have to fix the theta and epsilon to model this fuzzy granular cell. And as the processing of social network is very complex and it is highly consuming time, it is highly consuming high time. So we have processed this one in MapReduce approach, distributed approach, by taking five different computers and clustering them. These are the steps. First,
conclude in 2 minutes.
Yes.
Conclude in 2 minutes, please. Okay.
Okay. This is the steps. Actually, main step is to identify this granular embeddedness and granular degree of each of the community, each of the granules, and we have to include them in a community. And at the end, we have to measure the eigenvector centrality to measure the importance of each node, to measure the influence of the nodes. This is the same thing we have represented in the figure. These are the dataset I have used, Dolphin dataset and Ego Facebook. Ego means Ego network. Ego network in the Facebook, Ego network in the G plus, Ego network in the Twitter. You can see we have taken edges, billions of edges are there, and more than 10,000, more than 1 lakhs nodes or vertices are also there. So this is considered to be large scale network. So these are the four datasets we have used, and for the experimental purpose, we have used Hadoop distributed platform, which consists of 5 nodes, symmetric configuration, and for comparison purpose, as we have used distributed approach, so we have compared with other parallel algorithm which are already exist. Level propagation is already exist, and for the parallel version we have implemented that one, and we have compared our algorithm with them. Level propagation, K-click population, and modularity optimization. And this is the table. While we are fixing the value of theta and epsilon, we have experimental several times, and you can see here we are getting the more number of communities. So we have fixed the value to theta 0.7563, and we have fixed the value E to 0.5503. And by taking that value, we have model our algorithms. And this is our result, which are compared with other parallel algorithms. You can see this FRC, fuzzy rough community, fuzzy granular social network, which takes less execution time as compared to other parallel algorithms. So, in conclusion, now I am come into conclusion. Real social network are modeled into fuzzy granular social network where basic processing unit is granule rather than the single nodes. Fuzzy rough community may be considered for better representative entities of social groups in real-world network. Each node is associated with fuzzy membership value. Node is said to be a member of community if its membership value lies in the range of upper to lower. That is the limit. If the inside the limit that value membership value is there, you can include that nodes. The proposed approach is suitable for overlapping community detection. And after the communities are identified, influence of each community is detected. And for influencing purpose, we have used eigenvector centrality to measure the importance of each node. These are the references we have used. Any questions?
Thank you so much for the presentation. Questions, please. Questions, please. No question? Yeah. Can you explain what is the basic contribution in this paper in one line?
Yes, sir. My basic contribution is that we have modeled the general social network because a node may not be a member of a single community, and if it is a member of more than one community, it may have different degree of membership. So basic problem is to identify the degree of membership using fuzzy and graph set theory. So we have modeled the general social network into a different kind of social network, which is known as fuzzy granular social network. That is our main.
Okay, it's okay. Thank you so much for the presentation. In absence of any other question, I'm shifting to the next presenter. This is the
Yes,
yes,
I'm here.
Okay, please share your slide. Please share your slide.
Okay. Can you see my presentation?
Not yet, yes, Ilchin. Illis Technical University, right?
Yes, can you see it?
Yes, I can see it now. Please present.
I'm beginning. I'm Elçin Güveyi from Yıldız Technical University, and I'm research assistant at this university and a master degree student. Now I'm going to present our systematic literature review. It's about human factor on software quality. Why we researched about human factor? Because software development is a human-oriented process. So any factor affecting people will directly affect software quality and success. So in this study, we aim to reveal which factors affect humans mostly. So we made this review work. When we look at this SLR literature, we saw the last systematic literature review about human factor on software is from 2010. And some of them are very, very outdated, like 1985 or 1988. And some of them was focusing only one factor, like Beckham's work, they only focus on motivation factor. But in our work, we want to consider every factor and taking every factor from primary studies. So we specified our research questions. First question was, we want to learn what's the distribution of personal, interpersonal, and organizational factors that they research at primary studies. It means that personal factors are directly about human himself, like personal characteristics or technical backgrounds, experience, educational, that kind of factors. And interpersonal factors between people, like their relationships and communication, collaboration, and etc. And organizational factors about like organization and project parameters, like this way, like working conditions. They are under the organizational factors category. And the other question was, which software development step was research? We want to see that, software has some steps like analyzing, design, or management, or testing, that kind of steps. Which steps was researched mostly? We want to see that. And which data collection methods and which data analyzing methods are researched? We want to see that too. And we want to look which article types, conference paper, journal articles. And the other question was, what's the publication frequency? We take a look for year. how many papers published in 1 year. And the last question was, we want to see exactly which factors studied mostly on this software quality researches. So we made our search for primary studies. We looked for well-known for popular databases, IEEE, ACM, Springer Link, and Science Direct. And our search term was software quality and human effect or human factor on human issue, and the plural versions of these terms. We made this search at those databases. And our constraint was we only get papers published after 2009, so we only consider last decade. So we get more up-to-date results by this way. And we made this search at 9/9/2019, almost 1 year before. And from 4 databases, we got 30-50 papers total. And we applied some filters to this 30 and 50 papers. First filter was we excluded irrelevant kind of papers, like not English papers, secondary studies, tertiary studies. We excluded all of them. And then at the second filter, we made a TA key reading. It's title, abstract, keyword reading. And we want to ensure that this paper contains both of human factor and software quality terms. And at the last filter, we made a detailed reading, and we excluded irrelevant topics. Like most of the time, we see that human-computer interaction or user experience or usability analysis are searched mostly, but we excluded this kind of topics. We only consider software quality. And for data extraction step, we made a table on Excel, and we specify our columns by this way: article names, article IDs, and publication year, type, and development step. We just read all of this information to that table. And here are results. First question was, what's the distribution of this personal, interpersonal, and organizational factors? We saw that mostly those personal factors are researched, and second time interpersonal, and third one was organizational factors. And when we look at the software development step, mostly this development means implementation step, mostly research. A lot of paper was make their search on developers. And the second time we saw the test phase, and because testing is another important step for determining the software quality. And the question was data collection methods. When we look at the literature, we saw lots of paper use surveys, like online questionnaires to getting data from developers. They use questionnaires and surveys. And in the second place, they use data sets. Data sets includes collecting logs, comments, or project parameters. They use them, and some of them using experiments and interviews and observations. When we look at the data analysis methods, we saw mostly correlation used on the primary studies, and mostly a spearmint rank correlation was used. And the second place, they used regression, and some of our researchers use their own tool, and some of them using for non-numerical data, they used grounded theory. And when we look at the type of studies, mostly we saw conference papers, so we can say that this topic is mostly discussing at conferences. And when we look at the frequency of by years of the papers, we saw a fluctuation, and this way we can see the years. And the last question was, which factors research mostly? And we specified them as a word cloud. You can see lots of factors in here. And when I said this or detailedly, most researched personal factor, the researchers use mostly 2 types of type integrator. One of them was Big 5 characteristics type test, and the other one is Myers-Briggs type integrator. Big 5 gives it specifies 5 basic personal trait, and Myers-Briggs defines 16 kind of personal trait. And the other most researched personal factors are experience and education. These are very important things for a developer's productivity or its success. And when we look at the most researched interpersonal factors, we saw in the first place is communication. It's really crucial for developers or testers and between their relationship. And collaboration and conflicts are another factors that researched. And the last one, most research organizational factors was management. As management is really important for developers, and office conditions and team size and structures are researched mostly on this research. So as the conclusion, we can say that this SLR can be a guide for researchers in this field. They can research in a detailed way of these factors, or they can focus on different factors other than these. So thanks for watching.
Thank you, Elchin, for the wonderful presentation. In fact, the human factors are very important in software quality, but they are less studied in the literature. It is a very common factor. And in fact, 15 years back in 2006, I also started to work on the same issue, that how to this human factors and relation with the software quality. Thank you so much. If you have any questions, please ask.
Hello.
Yes.
Yeah, Professor Ali again. Thank you very much for this nice presentation regarding systematic literature review on the impact of human factors in software quality. I have one comment and one question. You didn't mention how many papers you selected at the end. You mentioned only that when you done the search on the four digital libraries, you obtained 1,350 papers. But how many at the end you have selected after applying inclusion and exclusion criteria?
Oh, at the last one we got 80 papers.
80 papers.
Yeah.
Okay. Now, maybe one question can be very important for your topic. Because here you just mentioned what are the human factors, and you classify them in three categories: personal, interpersonal, and organization. That's true?
Yes.
But you know, when you want to evaluate the impact of these factors on the software quality is a multidimensional attribute. If you follow, for example, the standard ISO 25010, you have 8 characteristics. You have functionality, you have reliability, you have usability, and so on. So maybe one question is very important for your systematic literature review is to know how these human factors not impact the characteristic of quality, not directly how they impact software quality. That's my question.
When we look at these papers, we just looked at if a paper contains software quality search, like some of the papers, like they were researching for some people are pointing the software qualities, and they're looking the developer's activity and developer's characteristic, and they found a correlation between them. So we get just these papers.
Thank you, Elchin. Thank you. I hope that you will interact with Professor Ali as well. He is a senior professor and associated with this conference in several years. We have one more paper. I think Miltias is also ready for the presentation. The SDK for education platform for embedded software quality improvement. It is also related to the software quality. Are you
Hello?
ready to?
Hello, Professor. Can you hear me?
Yes. Please present your last presentation of this.
Okay, thank you. I'm now going to share my screen. Just a moment.
Also, please on your camera, so we can also take a picture in all the groups. On your camera during the presentations, most of the cameras are off. Please present.
I would like to apologize because I don't have a camera on my workstation, but probably afterwards I can connect it to the laptop. So maybe after this presentation. So okay.
Okay, please.
Okay. So, can you see my screen and the slides?
Yeah.
That's great. Thank
Yes, yes, very well.
Hello, everybody. My name is Miltiades Siavas. I'm a postdoc researcher at the Center for Research and Technology, Hellas. And I would like to thank you for giving me the opportunity to present our work, which is entitled the SDK for the Platform for Embedded Software Quality Improvement. The purpose of this presentation is to give an overview of the SDK for the platform and to present the main novel functionalities that have been implemented so far. Actually, the SDK for the platform is the outcome of the SDK for the project, which is a European project that is funded by the European Commission through the Horizon 2020 program. The consortium consists of 11 partners that come from 7 different countries. The budget of the project is, the total budget is 4.3 million euros, and its overall duration is 6 months. We're actually heading towards the final 6 months of the project, so we can say that it is in a good state of maturity. The purpose of the SDK for the project is to provide solutions for monitoring and optimizing the quality of software products with emphasis on embedded software, especially with respect to 3 main quality attributes, which are maintainability, measured in terms of technical debt, as will be discussed later, dependability, and energy consumption. This is the high-level overview of the overall platform. It consists of 5 core toolboxes, which are the technical debt management toolbox, the dependability, optimization and energy optimization toolboxes, the forecaster toolbox, and the decision support toolbox. The first 3 toolboxes are responsible for monitoring and optimizing the 3 quality attributes of choice, which are the maintainability, the dependability, and the energy consumption, whereas the other 2 are responsible for facilitating the decision-making during the software development process by providing forecasts of these quality attributes, as well as suggestions for code changes that can actually improve the overall quality. Now, due to the limited time, I will go quickly through the different toolboxes, and I will focus mainly on the main features, the novel features that each one of them provide. The technical debt toolbox is responsible for managing the technical debt of software products. The technical debt, or in short TD, is a metaphor that's widely used as a measure of maintainability. The technical debt toolbox actually provides solutions for measuring and monitoring the main TD aspects of software. In particular, it reports the technical debt principle, which is actually the effort that is required for fixing all the quality issues that reside in software. The TD interest, which is actually the additional effort that it is required for fixing the quality issues because they were not fixed in the first place. And the breaking point, which is actually the main novel feature of the technical debt toolbox, which is actually the point at which the cumulative TD interest becomes equal to the technical debt principal. And it is actually the point at which the project becomes unsustainable. So it's very useful for decision making. Another novel feature of the technical debt toolbox is the TD analysis of the new code. For this feature, we focus mainly on the TD density, which is actually the TD principle divided by the lines of code, since we believe that it reflects better the quality of newly added code. Based on the concept of TD density, we define the quality gate. According to this concept, if the technical debt density of a new commit is higher than the technical debt density of the latest commit, then the commit is rejected. The developers have to improve and fix some quality issues in order to pass the quality gate and make their commit accepted. Technical debt toolbox also provides solutions for design level refactoring recommendations. Actually, it proposes different alternative designs that are better with respect to coupling and cohesion. It actually takes us into the initial design of the software application, and it provides us input to the genetic algorithm. This algorithm actually searches for the best alternative using a fitness function that optimizes the cohesion and coupling metrics. The best alternative, the optimal design, is actually presented to the user, and the developer can use this information in order to restructure the code appropriately in order to have better cohesion and coupling metrics. Regarding the dependability toolbox, important contributions have been made with respect to software security, which is actually an important facet of software dependability. First of all, a security assessment model has been developed which is able to assess the internal security level of a software application based on the results produced by static analysis. As can be seen by the figure, the model provides a high-level score with a security index that reflects the internal security level of the application. Apart from this, apart from the high-level indicator, it also provides finer-grained assessments. It actually reports the scores of different important security characteristics like confidentiality, availability, and integrity, or even some scores for low-level security properties, which actually highlight specific security-related issues that reside in the code. For instance, as you can see here in the given example, this application has a low score in logging, which means that it has a lot of logging issues that could probably mean that there are a lot of logging issues that should be fixed by the developers. The vulnerability toolbox also provides vulnerability prediction models, like those that were presented by my colleague Elias in the previous presentation, that actually are responsible for identifying, predicting the existence of vulnerabilities in software components. They are actually deep learning models that are based on text mining. They receive keywords from the source code and actually assess whether the different components are likely to contain vulnerabilities. The results are visualized in the form of a heat map. Each rectangle is actually corresponds to a specific software component, and the color denotes the probability of containing vulnerabilities. The greener the rectangle, the higher the probability for the given class or component to contain a vulnerability. As a result, this can be used by the developers in order to pinpoint the different hotspots of the system and understand and decide from which classes, from which software components the different testing and refactoring activities can start. Now, regarding the Energy Toolbox, the Energy Toolbox provides some high-level, application-level, actually, well-known energy indicators like the CPU cycles, the memory accesses, or the cache misses that are calculated using popular profiling tools like Valgrind and Linux Perf. However, the most novel feature of the Energy Toolbox is actually the identification of energy hotspots, which are actually the identification of energy-critical parts. In the given example, which is based on a real-world application, the Energy Toolbox, as can be seen, reports 5 different energy hotspots, which are actually functions that have a high energy footprint. The second important feature of the Energy Toolbox is the provision of recommendations for energy optimizations. It recommends how someone can actually reduce these memory footprints of the identified hotspots. It actually takes into consideration different hotspots and assesses them in order to define, to evaluate whether any important energy savings can be achieved either through source-to-source transformations or through acceleration, which means by offloading the hotspot to an accelerator, like a CPU. In the given example, we can see that for the fourth hotspot, the Energy Toolbox reports that the energy improvements can be achieved through acceleration by offloading the GPU or an FPGA program. The Forecaster Toolbox provides predictions for the future evolution of the quality attributes. In the given example, we show the PD principal forecasting, but the same holds for the other quality attributes. The green line corresponds to the PD principal of the different versions of the application, and the red line corresponds to the predictions that were made for 40 versions ahead. The detailed predictions are also provided in the form of a table. What we can see in the given example is that if no corrective actions are taken at the moment, in 40 versions from now, the technical debt will increase by 15.5%. So this information is very useful for project managers in order to decide whether they should focus on implementing new features, functionalities, or to focus on repaying some TD now in order to avoid accumulation later. The final toolbox of the system, the decision support toolbox, its purpose is to perform a trade-off analysis between the 3 quality attributes of choice and to actually to suggest code refactorings in order to improve the overall quality or to improve the specific quality without affecting the others. It is currently under construction and it's expected to be finished by the next 2 months. Finally, the SDK for the toolbox has been is evaluated through 3 different pilot cases from the airborne, healthcare, and automotive domain. We actually use embedded software from Airbus that is running on drones. from Erasmus that is running on implantable devices, and from Horizon that's running on smart glasses that are used in automotive manufacturing. In all these cases, the goal is to improve the specific quality attribute by also maintaining satisfactory levels at the other two quality attributes of choice. Thank you very much for your attention, and I will be happy to answer any questions. Hello? Hello, can you hear me?
Yeah, hello.
Yes.
Yeah, thank you for the presentation. And
thank you.
It's a nice time, and I think it is the end for this session. So I think it is 5 hours for us to be here in the sessions with me, with the moderator, and also Jay Pancham is also with me in the morning, right? It is second day, very tedious. Thank you so much, Andre. And I again request you to on your camera so we can take a picture now. Our session is very, very good. So in fact, I already took it. Yes, Robertus, hi, nice to see you. So a lot of my friends are here as well. You know that Professor of Software Engineering, Robertus from Kaunas University of Technology. He's a great professor in software engineering, and we are working since several years. He is also in the midst of the audience here today. So you know that yesterday we have the Robertus, we have the Ricardo. He is also a very great researcher. He was present in the. So time to time we are meeting with the great guys who are the expert in their